This is a production of Cornell University.
Hello, everyone. Thanks for hosting this crazy sequence of events today. We have a lot going forward, and I'm going to try to keep us on schedule. We have a lot packed, but that means also if you have questions, break it up because we don't need to talk up here. The whole point here is to look into this new pathway of transitioning to solids bedding if it's appropriate. There's a lot of thanks to go around the Gathering Barn and Pat Krast, who invited me to work with Justin and Rhonda. And Justin invited Mike Durant and Lindsay Ferlito. Craig Kramer and George Birch also helped me this morning with the tech, so super shout out for that. And then, of course, lunch is being hosted by Delta Keeney, and we'll see the delights later. So I'm going to talk about why a farm might transition. Well, I'm talking about the New York State Climate Inventory, greenhouse gas inventory. And why that has led me to advocate for manure cover and flare to destroy methane. But you'll see why I am the least relevant conversation in today's talk. All right, everybody who comes after me are going to be the super useful speakers. So in 2019, New York State passed the Climate Leadership and Community Protection Act. Sometimes it's called the CLCPA or the Climate Act. And what does it say? It says all sectors, oh my gosh, this is way too small for you all. All sectors in New York State must achieve a 40% reduction in greenhouse gases by 2030 and be net neutral by 2050. All sectors, apartment buildings, schools, industries, agriculture, right? All sectors. But we must do it cost effectively, and the state, we must do it without co-pollutants, we must do it equitably, and the mitigation must be real, permanent, quantifiable, verifiable, and enforceable. Those last 5 words are very important words. We could spend a whole hour talking about those words, but that's to ensure that what we're doing is real mitigation. It isn't fraudulent mitigation, right? There's lots of ways in which you can push things around and it doesn't get to the point of greenhouse gas mitigation. It says we must do it to minimize cost and maximize total benefits to New York State and encourages early action. And so some of the funding you're going to hear about today is to encourage that early action. And what is an acceptable cost? Anything under $130 per metric ton of CO2 equivalents. We'll get into that in a little bit, but just remember the number $130. And this is the idea of what future generations will pay in damages, right? From flooding events, from drought events, right? From extreme weather. So it's anticipating the costs in climate damages to the future. So justifying those costs today, in today's terms. And that these mitigation strategies must be real, permanent, quantifiable, verifiable, and enforceable. Those are my favorite words in this whole policy. They're truly meaningful, but we're going to move on. How do we get there? New York has already drafted a 445-page scoping plan. Do you have to read it all? No, but your section might be interesting to you. And they've published a document about equity in agriculture, for example. These are just 2 examples of the things that are being built out from this 2019 legislation. Okay, now I'm going to get into the inventory. So this is New York State's total greenhouse gas inventory. And what you can see at the bottom here is 1990 to 2020 on the right-hand side. Okay, and what is in blue? It's energy. The majority of our problem is energy consumption, right? We're pulling up fossil fuels. They've been buried. They've been truly sequestered. We're combusting them and they're being added to the atmosphere. The point here is energy is the majority of the problem. It's not agriculture, it's energy, and it affects all of us in all of our daily lives and all the things that we're doing. You can see here in this graph of energy consumption in the United States. And in 1850, we were almost exclusively all wood, right? Then we discovered these buried fossil fuels, which is just buried wood, and we started combusting it. So this is the source of our problem. What's interesting is also, this is the chart of New York State forests, and you can see that we were nearly deforested around 1850 because we were cutting down all of those trees in order to build our homes, open up space in order to grow grasses to feed our horses, and to heat our homes. But we discovered fossil fuels in 1850, and we transitioned to that. And what you see here is the regrowth of forest. This is a humongous carbon sink, and this is a great resource going forward. This is below zero. The green represents forestry, and so this is representing the carbon that's being pulled out of the atmosphere forest sector. So this is a great resource. And in orange, you can see agriculture. All right, it's 6%, basically. It's small. Here's where we need to get to as a state. Our emissions need to be at 0 by 2050. But here's where 40% is. And look, we're not so far away from the 40% reduction. What's also interesting to see is that as a state, our emissions are trending downward. All right, without even really trying, we've been reducing our greenhouse gases. Okay. So I'm going to just focus on the agricultural emissions right now. And what's important to know about agricultural greenhouse gases is that there's 3 important ones. For society at large, we're just thinking about carbon dioxide from fossil fuel combustion. But in agriculture, we need to think about methane and nitrous oxide, methane CH4 and nitrous oxide N2O. And the reason for that is that methane is 84 times as potent of a greenhouse gas than carbon dioxide.
On a 20-year scale, right?
On a 20-year scale, which is New York State's rule.
Yeah, but different than how everybody else is, right?
Correct. It doesn't change, however, the priorities of action, and we'll get to that. So it's not that agriculture is producing large quantities of methane and nitrous oxide. It's that this multiplier of 84 and 264 makes a small amount of methane or a small amount of nitrous oxide have a large value. Does everybody get that? Okay. So if you have 1 pound of nitrous oxide that is being emitted, that's equivalent to 264 pounds of CO2 being released. All right. Just to get this idea going forward, 1 pound of methane is equivalent to 84 pounds of CO2. Here is the national inventory. This is the US inventory. And you can see down here the pie chart for the whole country in blue is all from the energy sector, and it's all carbon dioxide. And nationally, agricultural greenhouse gas emissions come in this little bit of the pie. About 10% is in the red piece of the pie, which is agriculture. If we look at the national emissions, the agricultural soil management is the largest source of emissions across the country. And this comes in the form of nitrous oxide, right? We are a huge cropping country. And as a result, we use nitrogen, and you multiply it by 264, and you begin to see how nitrous oxide nationally is the most important greenhouse gas. The next 2 parts are methane and nitrous oxide that comes from enteric fermentation, right? The burps and farts of the cows, as well as the manure management, all right? So you can start seeing how nitrous oxide and methane become the predominant greenhouse gases in agriculture. These other ones are the sources of carbon dioxide, and they're much, much smaller, and we won't talk about them today. So now we're going to look at New York State's specific emissions. And here's our pie chart. We're 86% methane, and it comes predominantly from the enteric fermentation of our dairy cows. Sorry. Predominantly comes from this blue bar, which is enteric fermentation from cows, and methane and nitrous oxide from manure storage.
And
Yep.
isn't that- we still have tons of cropland, right? So is it because of the 20-year accounting that sort of emphasizes methane and de-emphasizing jet fuel emissions?
If we use the traditional 100-year global warming potential, methane would be 75%. Okay?
Yeah.
And so it's still a thing that needs to be done. So remember that the global warming potential, I think everybody likes to get sidelined by it. What is our goal? To be net neutral by 2050. It doesn't matter what global warming potential you're using in 2050. We need to be net neutral, right? We need to get those gases down or displaced. So don't get hung up on it. I suggest not getting hung up on it, but then of course, that's what I'm suggesting. You can suggest whatever you want to suggest. Is everybody clear on that? It doesn't really matter which global warming potential. Methane in New York State is our primary objective for agriculture. Okay, so here is the pie chart for New York State of our current emissions, and you can see here's agriculture in pink. I just want to point out that the electric sector is all natural gas here, but we're not seeing any of the solar, wind, or nuclear that's part of it because that's not part of the emissions, right? We've already cleaned that up, so it's disappeared from this pie chart. This is just a pie chart of the stuff we need to do. To recap, US agricultural emissions are about 10% of total, and New York State ag emissions are about 6%. Nationally, we have almost 1 billion acres of ag land, right? That's where the nitrous oxide is coming from. And New York is the 4th largest dairy state. So that's why we're dominated by methane. So traditionally, if you go to a farm that's a cropping farm, you should just work with them on their nitrous oxide emissions. If you're going to a dairy farm, you should focus on their methane emissions. And here is a timeline from 1990 to 2020 of ag emissions over time. And you can see that there's been a 41% increase in our emissions in agriculture. So while the state is going down, agriculture emissions are going up. So what is the dominant source of these emissions? Enteric methane, the burps and farts from the cows. And here's the great news. There is only one exemption in New York State's legislation, and that is for livestock. Does everybody get that? This is a really considered fact in this policy, and this is why I love this policy, because these are animals. They are not machines, right? They have this unique biology, and they happen to produce methane. That doesn't mean as a state we don't need to get down our total emissions to become net neutral, so we grow more trees, right? There are hard to decarbonize things like jet fuel and dairy cows that we will find other ways to mitigate. But right here, you can see that already 3% is not your obligation. That doesn't mean people want you to stop working on feed efficiency. Of course not. But what it does mean is like, this is not your, you should just relax and feel supported, in my opinion, by the policy. And what you can see in this trend is that the dairy herd size has gone down, but the milk production has gone up. So with 18% fewer cows, we're producing 40% more milk. And this is just a tribute to how great the dairy industry in the state is doing in terms of addressing its greenhouse gases from the enteric emissions. I'm going to skip this. This is what I'm going to focus most of the rest of the talk on, or the reason for the genesis of today's workshop is this 31% of emissions from agriculture right now, which is from manure management. Anybody want to guess why our emissions have gone up since the 1990s? Manure storage, right? What is the antidote for liquid manure storage? Why does a liquid manure storage produce more methane? It's anaerobic. So what is the obvious answer for mitigating that anaerobic manure? Yes. But nobody's gonna say it.
Store less manure in the summer.
Store less manure in the summer. Daily spread, right? It's aerobic. It's not gonna produce the methane. But why aren't we gonna do daily spread? For water quality issues, right? So we have these liquid manure storages, and until we figure out a different way of thinking about it, we can cover and flare, or we can reduce the time that the manure storage is in during the summer months when it's hot and it's just like pumping out methane, okay? Okay, so you've already figured out, this is just a chart of our increases. And this is Jason Oliver's work with colleagues evaluating the methane emissions from a manure storage. Okay, so these are where our goals would be for 40%. We need to get to here and 85% by 2050. But again, remember, this part is officially exempted. All right, this is another way of looking at our emissions total. And you can see enteric emissions are about 14 million metric tons, and manure management are about 6 million metric tons. And nitrogen from the field is about 2 million metric tons. Some things are not included in this. Energy is counted in the energy sector. It'd be about another 2 million metric tons from energy. But because of accounting purposes, it's not counted to the farm, it's counted to the energy sector. And also, about 20% of New York farmland is in woodlands. So the wooded component that is sequestering the carbon, that's counted to the forestry sector. That doesn't mean we can't think about a whole farm plan that includes these things. It just means that in terms of the state's accounting, that's where your energy and that's where your forest emissions and sequestration are going, right? They're going to other sectors, not yours. And here we are showing 6% of agriculture in the total of the state emissions. Okay, I already did that. So there are some mitigation opportunities. Feed efficiency. New York has done great on feed efficiency, and we can do better, but it's going to be hard work. All right, and we estimate that that could be about 2 million metric tons reduction by continuing to improve feed efficiency, which hopefully would reduce costs, right? Because less food is going in and more milk is coming out, which means less methane is being produced, right? So that is a hopeful feed efficiency. That's very ambitious because you guys have done a great job already, right? Nitrogen use efficiency, we identify about 0.2 million metric tons. But if we were to cover and flare a majority of the existing manure storages, we could reduce about 4 million metric tons of CO2 equivalents. Adding these all up, these are technically capable things that we could do. We have about 7 million metric tons, which is 30% below our current emissions, right? What is our goal? 40% by 2030. All right, so right here, we've got 3 real opportunities to work on. And this isn't pie in the sky, high technology. If we also looked at, we have 2 to 4 million acres of idle or underutilized land. I hate those terms because whatever is living there does not think it's idle, right? But nonetheless, we've got what we call 2 to 4 million acres of idle land. And if we just planted trees on 1.7 million acres, we would have another 5 million metric tons. Adding up all of these 4 activities together would get us 52% below our current emissions. The point here is these are doable things, and they have lots of co-benefits, either cost savings, water quality, or long-term, long-lived wood products for next generations, right? Okay. Okay, I'm gonna skip that. So trees are great, and I recommend paying attention to your wooded lots. And we're gonna just talk about this cover and flare opportunity for this increase in almost 300% increase in greenhouse gases from manure storages. So I presented last summer to all the soil and water conservation districts, these next slides, and I'm going to go through them very fast. And I'm in these meetings, I'm advocating for cover and flare, right? There are all these co-benefits. You can address odor. You don't have to haul the rainwater. There's less tractor passes, blah, 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 blah. We're not going to talk about cover and flare today, but cover and flare is a great way of reducing the methane emissions from these manure storages. And I show examples of people with covers and flares and the ways in which you need to plan around the whole farm for cover and flare systems and where the manholes need to be and where the emergency vent needs to be, et cetera, right? There's all these things where you need to move water. I show all these slides. This is what the liner looks like. You probably already know that. This is the trench that you put the concrete in. This shows the sealed seams over here and the water accumulating on the top and how you have to pump off the water. And this is the pumping off of the water on Dale Stein's farm. This is your emergency vent. This is your actual flare, right, to burn the methane off. And here's the flow meter, and there's a temperature meter, right? The flow meter shows that the gas is going through. The temperature meter shows that it's burning, right? That's how you know that the methane is getting destroyed. So me, Jenny, the biologist who grew up in rural New Hampshire, drank whole milk my whole childhood. I love dairy cows. I love dairy products. Grew up in a really conservative family who, my father would require us to think and articulate what we wanted in the refrigerator before we opened the refrigerator in order to save the energy in the refrigerator. Okay. I grew up thinking that my family was an environmental family. My family was a conservative family where you conserve resources and you save money. But that's not what happened. I turned into an environmentalist. And so I love this cover and flare because you have real, permanent, and verifiable mitigation. You don't have to go out into the field a million times. You just have to have the flow meter tell you if it's hot and you know it's burning. Okay, 5 minutes. The reality is, at that meeting all summer long, everybody was like, yeah, but 50% of these farms have sand bedding. And you can't cover and flare sand when it's in the storage, right? So that is the reason for today's meeting, right? Subsequent to that meeting, everybody says nobody really likes sand bedding, but the cows are healthy. So who here in the room is using sand bedding? 1, 2, 3. Okay. How many of you love the sand bedding? What are some of the problems with sand bedding? It destroys everything. Like what?
All your equipment.
All your equipment. Okay. And how much does it cost? I asked Jason this, and he, I think for 1,000 cow dairy at $20 a ton, that's $180,000 a year in just sand bedding costs. In 5 years, that's $1 million of sand. Okay, so the point here is today we're going to talk about solid liquid separation in order to potentially use the solids for bedding. We're going to hear about herd health and how this can affect herd health. We're going to hear from 3 different farmers that have had different relationships to sand bedding, moving away and moving back towards, as well as thinking about nutrient management and the new P-index rules. And we're going to end with a funding panel. And at the very end, we're going to have a farmer funding panel speed dating event. So you should have all gotten in your packet a sheet that looks like this. It's 2-sided. And in it, we're talking about in different sections, just simple separation in the first section. And the second section, you're talking about herd health considerations. On the back is storage and cover and flare options. And what we would like you to do today is think about what do you already have in terms of this sequencing and what do you need or what do you want? And to see if any of those things match, right? Maybe you need a housing for a separator, but you don't need to have an electrical line pulled there, right? So in the speed dating, you can talk to NRCS and Ag and Markets and Soil and Water and think about what kind of funding might be available for you to pursue any one of these objectives. So if you just identify one thing on that list that you would like to do, you have an opportunity to think about how realistic is it for you to apply this year, or how you might think about applying for it next year. And there's all kinds of activities in there, right? You can groove the floor so that the animals are not slipping in the transition from sand to solids bedding. Okay, there's tons of, I'm going to stop right there, and we're going to, Ken, can you start sharing the screen?
Hello.
So our next speaker is Ken Van Slyke. He is from Western New York. He is also a dairy farmer who converted to separated solids and now runs a company that sells separators. So he's very committed to separators as an option.
Okay. All right. Good morning. Thanks, Jenny, and thanks, Rhonda and the folks with Jefferson and Lewis County for inviting me to speak about this a little bit. Just give you a quick background. If this will proceed here. Okay. So yeah, quick background. For those of you that don't know me, I'm a lifelong dairy farmer in Western New York, Wyoming County. And I started messing around with separation over 25 years ago and multiple applications, including with our own farm, and advanced on to be a dealer. And I spend as much time consulting as I do actually selling when it comes to manure handling and processing. And we also, to give me a little more credibility in this conversation, have our custom farming service where we spend a lot of time agitating different types of lagoons with different types of manure, with farms using different types of sand or solids or sawdust or things like that. So that's where I'm coming from in this conversation. We're going to talk a little bit about the rudimentary basics of separation and how it applies to different manure systems and bedding systems on New York farms based on our customer base and the experience we've had, along with what we've learned in cooperation with the fine folks at Cornell and ProDairy and folks like Jenny as we move this into the conversation of greenhouse gas mitigation. So again, let's just talk about some basics. We're going to separate the solids from the liquids from a typical cattle slurry. Usually that means the solids being the majority of the bedding that you're adding into the stalls, along with the fiber that the cows pass. There are a few different methods mechanically that we can approach that, particularly in our region and our climate. We can take that to another level and remove nutrients or finer solids with more intensive separation methods. That's kind of a secondary conversation to what we're covering today, as well as what we would do for different methods to remove sand, which isn't always mechanical. But basically, we're going to talk about really only mechanical separation and not so much the passive version, because it's not that well utilized in our region, mostly driven by climate. This is all stuff we probably well know. The popular three that we see around New York are sand, sawdust, and paper pulp, depending on the little pockets you might be in and availability of the types of bedding material. They all have their pros and cons with overall farm footprint, water usage, parlor management, stall management, things like that. And we can go back and cover some of the differences and pros and cons to each one. So sand, again, I'm just going to kind of go quickly through these. We all pretty much know this, inert material. It's comfortable, it's cool. And I would highlight the last point there. It's pretty forgiving bedding product to put in the stall for a more passive or low intensity management of stalls and milking management. Jenny touched on this already. It can be pretty costly, not only to purchase, but to handle. And then once it's in the manure, I think it's not an exaggeration to say it can be a nightmare. It wears things out, it settles in pits, it increases your costs of agitation and hauling. And here's one, the last point I think is important too to talk about that I don't think it gets talked about enough, that if in certain soil types, adding that much sand directly to the soil can actually change your soil properties and leaching properties. As we talk about runoff and leaching as our next challenge here with new permitting coming up, that's something to consider. So two major points here, again, with the cost, you're buying in a product that just adds to more manure volume, and it will settle out quickly. Even if you think you're recovering a high percentage of your sand to recycle, the remainder is gonna settle out and be really difficult to work with in your storages. Sawdust, again, we know all these things. It's become a little more scarce in certain areas around the state in the last few years. There's a big difference in some customers' minds between green sawdust and kiln dried, not only in availability, but cost as well. And sometimes sawdust, the biggest problem with it is that it will potentially bring in foreign pathogens, particularly in the wintertime, that can create problems with udder health. And my rule of thumb with bedding, no matter what type of bedding you have, is having bedding is more important than no bedding, meaning it doesn't matter what type it is as long as you have it. And that's where one of the drawbacks with sawdust comes in, is that sometimes you just plain don't have it, and that's a real problem. Again, adding to the manure volume from what you're buying in. So you're basically paying a fee to bring something in to add more manure to handle. And it can, depending on the type of sawdust, or if it's the really chippy crushed pellet type stuff, can be difficult to deal with, almost as difficult as sand to deal with in storage and pumping systems. The recycled paper, again, it kind of depends on where you're at in the Northeast as to how available it is and what the cost might be. Depending on what kind of blend you're getting, a lot of that product has lime or clay in it, and can be a bit of an issue with manure storage as well, with settling out. Some independent studies that we did, this is going back, I'm going to say maybe 20 years now. That product coming into the stall was actually a higher bacteria load than recycled manure solids. I'm not going to say that that's how it is now or that's how it always is, but over the course of a year, we took random samples, both fresh and 12 hours in the stall, and the bacteria load was not only higher, but it was a foreign pathogen to what was already in the cow's environment, which could create problems with udder health. So those are some typical, high points of the different common bedding that we see around the Northeast. So let's talk about why we would separate. And really, it's all about this right here for the sake of this discussion. Jenny pinpointed really the low-hanging fruit of what we can do to mitigate greenhouse gas and improve as an industry. And it doesn't matter if it's a covered lagoon or a digester, which is a hot button topic now. What we do with bedding and how it fits into the rest of our farm system, particularly the manure system. The bedding is a major component and a major consideration of what we do going forward. So some of the benefits, for this discussion, again, the lagoon cover or some sort of methane capture or production like a digester. What we found is that the storage of the solids and liquids are easy to store as long as you have the proper management. The liquid effluent, for those of you that have experienced it, know that it pumps with far less horsepower, far less energy, and is much more consistent for storage and agitation when it comes to the nutrient management side of your farm. The solids are stackable. We found in different farms that not only can we utilize them in creative ways for nutrient management, but it's been a pretty profound way of improving neighbor relations. Pretty much immediately off the separator, the solids do not smell anywhere near as much as the raw slurry. And we've found in our own experience, as well as the experience of many of our customers, that it's a great tool to work with your neighbors that have manure management concerns around their house, or, you know, if they happen to have a summer party going on, how best to work with them. It also can extend the storage capacity of your existing lagoons. Depending on the type of separation you do and how intensive it is, we can see typically from 12% all the way up to 30% reduction in volume of your total manure through different forms of separation. And that reduction comes from the exporting of the solids. Let me be clear about that. It's not magic where you separate and suddenly you have less manure to deal with. You just have two forms of it, and you've extended the capacity of your liquid storage. Some other value-added options, and it's not real for everybody. It's another enterprise, so to speak, of what you would consider. But by having the bedding, first and foremost, that's what's going to pay for the whole system, and it's certainly the quickest payback. There are a few other steps we can take. Taking some of the excess solids that you don't make into bedding, composting it, and working with crop farms or CSAs, vegetable farms, or just direct to consumer. I can tell you from experience, after 14 years of operating a compost entity, that it isn't for the faint of heart. And if you think dealing with cows can be difficult, dealing with different consumers is a whole new ballgame. But one more step beyond just making bedding is the nutrient removal, where it shows a lot of promise right now. I think it's still in its infancy as to how we can practically apply it to the New York dairy industry, but nutrient removal has a lot of promise in keeping us ahead of the curve with the changing P index, for example, as well as concentrating a high valued product for us to afford to haul to further away land base or possibly market to those neighbor crop farms. So some of the drawbacks, I've heard this many times from some of the older generation of farmers, is why would we make two problems out of one? You scrape it into a pit, it sits there, and then we haul it out. And if there's a pile of sand left in there, we deal with it every other year. Or there's just a lot of the mentality of, I'm not going to make two problems out of one by separating, and that's a fair idea. But it's kind of hard to keep going that way and meet today's needs, not only for this discussion with manure storages, but also nutrient management and overall storage capacity. So yes, we have to invest not only in separation itself and figure out how that's going to pay back. We're going to probably have to invest in different ways of handling both the solids and liquid. Not everyone has efficient ways to store or spread the solids. Not everyone has the best way to handle the thinner liquid. And I think that's something that's overlooked sometimes is if you have hilly ground and you think you're just going to top dress the separated effluent, you're going to have some real runoff problem potential. So injection pretty much goes hand in hand. But I would pose the question, is that really a drawback? I mean, the industry needs to be headed more and more towards injection as it is, for nutrient management and runoff concerns, and also the efficiency of offsetting the high cost and availability of commercial fertilizers. So mechanical separation, as I started out with, it's kind of our focus. It's certainly the most common, and it's always the first step in processing manure. It doesn't matter if you're looking at recovering bedding, just simply separating for nutrient management, separating to make compost, separating for nutrient recovery. Getting the bulk of the fiber out is always the first step, and the best way to do that or pay for it is to produce bedding. It's the most valuable thing you can do and the simplest first step to offset the cost of your investment. The nice thing with mechanical separation is it's very predictable. It's very measurable and manageable when it comes to how much you're going to recover, what the dry matter is going to be. We can manipulate that in a pretty broad range of dry matter, not only for the sake of stacking solids, but again, going back to, targeting the ideal bedding product. So what we typically see in our systems through just a simple, what I call one-stage separation is a partitioning between solids and liquids. We usually start out with about 8 to 10% scrape manure if you're scraping your alleys and not flushing. And we collect that, separate it, and we end up with something like 3 to 6% solids in the effluent in the lagoon, and anywhere from 30 to 40% dry matter in the solids fraction. The 3 to 6 in the lagoon, especially towards the 3 side, is really like brown water. And when we get much below 3%, it's a mostly suspended solids, where it takes much more intensive separation to start to capture that and get us down even further. We did demo a system last year where we were well under 1% solids in tea water through some chemical and mechanical separation, and we can talk about that more later. Again, mechanical separation, screw press is certainly the most common. There are lots of different brands and ways of going about it. The concept is the same. It's in the details as to how they are built, to determine how successful they are, or how efficient they are, or how dry the solids will be to work with. I won't get into the mechanics of that too much, but that picture kind of gives you an idea of what we're talking about in case you've never seen one. We can scale these to any size dairy. There are different sizes. There's some even bigger ones coming along here in the near future that are kind of like a 4-into-1 size machine. We can manipulate that dry matter, like I said before, really anywhere from just stackable at 25% to well over 40% for high quality bedding. Again, some more examples. This is ranging from 300 cows to 4,500 cows with these examples here. This is what some of the bedding looks like in the stalls. And if I could talk about that just a minute, generally, and this isn't everywhere, but generally we see very high acceptance by the cows almost overnight, and it doesn't matter what you switch from. I can't exactly explain it other than if you ever handled the manure fiber literally in your hand, you'd realize how nice and soft and comfortable it is, even compared to sawdust. Generally, we do not see dirty cows, dirty udders, or dirty teat ends. In many ways, the parlor staff are usually shocked by how clean the cows are coming into the parlor. And it's a very nice absorbent material and comfortable to the cows. Some more examples of mechanical separation. The rotary drum, it can be utilized for those that are looking for high volume throughput, or pre-thickening if they're on a flush system. We can get it down to something closer to that slurry that we can then squeeze a little tighter to get drier material. This is also a form of mechanical separation to remove solids through a sand system. And we can take another look at that. Typically that's the bottom picture there is what it looks like coming off. So you can see it probably starts out as something like a low percentage solids, 4 to 5% solids, flush material, and coming off the rotary drum is going to be a thicker slurry. Usually this slurry is put into another step of the process to get a stackable product rather than just simply put it into another form of storage, because it would still have to be stored as a liquid. Here's an example of the pre-thickening from a flush dairy going into screw presses, and you can see the end product there. So we can start with a very low solids content, high volume, and still manage to get our nice dry bedding. Again, scalable. This is on a 6,000 cow dairy. And then we're going to talk a little bit about the mechanical separation for sand. There's a lot going on here. Is it necessary in every application? No. But I use this as an example of if we're talking about possibly getting close enough to removing enough sand for the sake of covered lagoon or digester, this is a pretty typical multi-step process to get there. So we start out with, oh, arrows aren't working again. There we go. Going to start out with a sand flume. Everything comes out of the barn into this lane to get the initial settling. We're going to go from there. The lower sand content slurry is going to go through those feeding augers, lift augers into mechanical separation. The liquid fraction is going to go through that rotary drum that I just showed you to remove some organic solids. And then we're feeding into the screws, that are constantly turning in that high abrasive sand, with water being added through this whole system, fresh water being added through this whole system to flush the sand away from the organic solids. And then we drop from that into a vibrating screen, again, dewatering, trying to get a drier, cleaner product. From there, they go into a feed auger that then go into a sand bedding dryer. The dryer is, debatable as to whether or not it's necessary, but it's quite popular in the Midwest at the moment. My question with that is, here we are trying to reduce greenhouse gases and use of fossil fuels. As Jenny identified, energy is our biggest culprit in our country at the moment. And here we are adding to the problem for the sake of, sticking with sand. Now, my comment, I guess, on this, and this is based on experience, is there's an awful lot going on here to reach a somewhat acceptable level of sand removal when it comes to storing under a cover or feeding into a digester. But my experience with this also is that it takes very little to get this off track, where your recapture rate of sand drops to a very unacceptable level to put under a covered lagoon. So it's something really to consider. What methods are you going to have to clean your covered lagoon or clean your digester out in a very short period of time after you've installed this huge capital investment and continued to run it? So it's just something to consider when thinking about sticking with sand. If your longer term goal is your overall farm footprint and greenhouse gas impact, etc. More mechanical separation related to sand. This also is tied with a small sand lane and a smaller scale. We also have a example of this at the Cornell vet barn. It's kind of a one-off system. It's a little bit of unique equipment in there, removing solids and sand, including a screw press to remove the solids to get cleaner flush water to make the sand separate better. So it's a unique closed system. This is just an example of the overall footprint that can be associated with trying to recapture sand. It's not only taking up valuable space for cow barns or cropland, it's also a lot to manage, particularly in our colder climate, and in comparison to what the separator building would be by itself. I think in talking with this comes from my experience on a lot of farms, but it also comes from hosting many tours on our own farm, as well as having conversations with our compost, farm consumers, so to speak. They're very concerned about the size of these farms. They're very concerned about what we do with fresh water, and they're very concerned about the visibility of the footprint of our manure system compared to just the nice pretty barns. You can take it for what it's worth, but that's a common theme with non-farm folks. And as we become more concerned about our, I guess I'll say the dairy industry's image and who we're marketing our product to, then it's something to consider as we move forward. Excuse me. Sand lanes and cleanup after sand lanes. This is a pretty efficient way to do things for sand reclamation. It is not necessarily a very high sand reclamation system. This typically is in the high 80s to at best low 90s of sand reclamation. So again, you're leaving roughly 10% of your sand behind to eventually go into your manure storage. And I don't know that that's conducive to have it covered. So doesn't matter the system, whether it's sand lane or mechanical, we really rely on a big difference between the fiber and sand and trying to get them separated from each other. Inevitably, to do a good job with it, we need a certain level of certain amount of fresh water, which seems really counterproductive to have fresh water added to our manure volume annually. If we want to reclaim that 98% or so of the sand, I think that's a pie in the sky number. And it doesn't take very much to get off track from that. And you quickly drop down closer to 90% recovery, which I think is a real danger zone for trying to store the long-term liquid. And I can assure you that I see this regularly, not only as, from a dealership or consultant standpoint, but we have a booming agitation business with our lagoon boats because of those who are, storing sand, even sand separated effluent in lagoons. It requires a great deal of effort to get it homogenized and out of the lagoon. So some challenges or things to consider in making the switch. If you this is something that we could spend a whole day on alone. But what can you think about with your facility if you'd like to switch from whatever your current bedding system is to move on? Are we looking at reusing some existing facilities? Do we need to start from scratch? Three-phase electric is really critically important. Not only does it make it very expensive to work off single phase, but it can be darn right impossible to get everything done in an efficient manner with the size of some of this equipment. What do we have to change for equipment, if anything, in terms of pumps, collection line or transfer lines, collection pits, anything like that? What do we have to change for manure spreaders? What do we have to change for liquid application equipment? Touching again on the idea of it really should be injected if you're working with the separated effluent. And then I think some very important points to follow as you go through this process of exploring the ideas, definitely have a relationship with a qualified and experienced engineer, somebody who's done this before, even if it's somebody that hasn't, find somebody that can consult with those who have. I think that this next point is incredibly important. Visit the facilities in your area. Talk to your neighbors. Talk to those who have done it. There are a lot around New York that have been doing this for going on 30 years now, and even more so in the last 15 years. I think it's somewhat foolish to just try and reinvent the wheel without seeing what your neighbors have experienced and pros and cons of the things that they've tried. Definitely want to draw on all the resources that are around you. I think some of the folks are right in the room there today, between Jenny and Kirsten and Jason. I don't know if Lauren's there or not. They are a great asset, and they have a very neutral point of view as to what works and what doesn't. They've done the studies and the research. Your local soil and water, they can help a lot in connecting you with the funding or the regulations that you should follow in your particular locale. We find that regularly that certain certain farms are eligible for highly sensitive watershed grant funds, or they have different regulations because of their soil type, et cetera. We all know that. This next one is a little bit tongue in cheek, but it's pretty true that if you don't have a veterinarian that has an open mind or a neutral view on how you can adjust your management to work with a different bedding or solids bedding, it probably won't be successful. And I've seen over the years a pretty big spectrum of how open-minded some vets can be. Some actually threaten to leave and no longer be the farm's vet if they are going to go off sand. That's how dogmatic they are about it. And then of course you want to include your CAFO planner. It's the nutrient management changes and your farmstead changes can be significant, depending on how you switch your bedding and the trickle down effect in your nutrient management. We want to definitely, as we develop these plans, we want to have a longer term view. How would we put this together to adapt to new technology? Would a digester be in the future? What are the contingencies? What if this doesn't work? How do we revert without wasting an investment? Things like that to just think about. And the last two are, from a personal standpoint, are you really ready to make the adjustment in management? And I'll talk specifically about sand to solids for a moment. There's some major points that in the management of bedding that have to be adjusted going from sand to solids. And are you ready? Is your team ready? Are they invested? Is your herd manager invested? Or are they going to fight you on it every minute and immediately point fingers as soon as something doesn't go right? And for the most part, we've seen very successful transitions, but on a rare occasion here and there, we've seen, a farm owner, quote unquote, cramming it down the throat of their team, and it doesn't end well. And if you're not ready to follow the plan, meaning how you collect manure, how you mix manure, how you feed it to the separation equipment, if you aren't ready to follow the rules of what we established in the layout of the system, then it may not be for you as well. If you're going to stick to, sort of the way you've always done it, it may not be successful. So I mentioned the major points and things that we have to change in management going from sand to solids. We can successfully use solids in deep beds, and how we make that transition from day 1 to day 30 is different here and there. It can be certainly a challenge and frustrating. It's not very easy to get the sand out completely. It's pretty much impossible to get the sand out completely and get to switch to solids. But for the most part, those who have used solids in deep beds have been successful with the right management. How do we replace the traction value of sand in alleys? That is probably the biggest challenge that farms with sand present to us. And, between wintertime slips and falls, or the connecting barns to the parlors, any inclines or steps you may have, good enough traction to detect heats, that can be a real concern. Generally, what we see is the alleys being scabbed with that really shallow texturing, grooving. That's usually the first step a lot of farms take, and it's different everywhere, but for the most part, that lasts 2 to 3 years before they have to do it again, and that seems to be a valid replacement for the sand traction. One of the bigger things in the day-to-day management is the bedding frequency, and sand farms are usually 1 to 2 times a week bedding, and grooming maybe 1 to 3 times a week. With the solids, especially in deep beds, we have to think about bedding pretty much every day. And we have to think about grooming those deep beds at least once a day. The most successful farms on deep beds are actually grooming 2 to 3 times a day, pretty much every milking. And then fighting the residual environmental sand as we make the transition, that can last as much as 6 months, getting that worked out of the barn pits and transfer lines and separator pits. it can be pretty expensive on the mechanicals of the screw presses. And how we try and remove the sand before it hits the screw press can be a key component in the success of this thing. So just a brief example of a typical facility. That facility housed, that had about 10 times more space than required for the screw presses needed for that size farm. It included a lot of solid storage. Typical collection pit could be inside or outside. You'll see the masts here. These are mixers or pumps. Actually, these are pumps, but something just like this would be across from the pit, and they would be a mixing component. Right here's an example of the same thing, pump and mixer. This is a typical type of slurry consistency that we want to see for feeding the screw press, whether it's directly from the barn or by pre-thickening if it's a flush situation. Many cases we use the separated effluent to feed back into this and get this homogenized at the right solids content. I kind of joke with our customers that you need to be a shit whisperer, because you have to be able to look at that and just know what solids content is there, and work with it, know that it's going to be consistent for the separators. Not a great picture, but that's the separated liquid. You can kind of tell the difference between the two here. You got a more, thinner chocolate milk consistency versus a slurry. Just an example of what I spoke about, agitator and pump. They don't necessarily have to be submersibles. Just an example. The solids conveyance. Most of the facilities that we're building from scratch these days are removing conveyors altogether, and we're just setting separators up in a room above a commodity shed bay of sorts, and the solids are dropping by gravity right into a pile. Controls, we have tons of levels of sophistication for controls, from controlling on your phone anywhere you can get a text signal to automation. We have certain facilities that are spread out over the size of 30 or 40 acres between pits and lagoons and separators, and they're all communicating with each other with pit level and separator speed and effluent pit level and all sorts of things. So you can build as much sophistication into this as you want, and of course, when it works, it's great, and it also frees you up to be out doing farming rather than babysitting manure equipment. I'll just touch briefly, I think I got another minute or two, right, on nutrient recovery. As I mentioned earlier, we set up a demo system in Cayuga County last summer to demonstrate the removal of the suspended solids and get us down to a very low solid content tea water and a very high phosphorus concentrated cake. And it shows a lot of promise. It's another layer of management. It's another cost, but we think that there's a lot of promise there, especially with the changing regulation sort of driving that. And then with that, I kind of wrap it up. And if there's any questions or discussion, I'm happy to participate.
Any questions for Ken?
So he mentioned a large number of farms that have been doing this for years, and solid separation, and many more that have adopted it recently. Are they also implementing covers and flares? Are they moving in that direction, or what's happening with that population?
I have to repeat it. So can you mention that some people have been doing it for 30 years for solid liquid separation? And there are some new people who are doing it more recently. Are those new people who are doing the solid liquid separation now doing also cover and flare?
I would say that the really large majority that are doing it for bedding reasons. And the idea with the cover and flare has been even more recent than that. And what we're seeing now for the newest projects, they are going hand in hand, whether it's a digester or cover and flare, the funding that's behind it, and the cover and flare sort of being the final straw for somebody to make the decision to proceed with this idea is very recent. But the last 5 to 10 years has been driven solely on we need a better bedding to work with, more consistent, more reliable, and we need better nutrient management from it.
Any other questions? Go ahead.
The screw press is, using fresh water, does that help the liquidations of getting out what you want out, just for the separation of solids? Or is that not going to be?
So Ken, when you use the screw press on separation for just the solids, no sand, do you need to use any fresh water?
No. The only fresh water used is when you wash the machine about once a month.
In our case, we put the separated liquids back in if it needs to be diluted down one. Right, the same tank right next to it, just recycle it right back in.
Well, I've tried to do sand before. Fresh water was the only answer.
Okay, so no, we don't use any fresh water.
But
Dale Stein has reported.
I heard, yeah.
Okay,
I would have said the same thing to expand on that, Dale. So thank you.
Part of the wash water goes in to that newer system.
Yeah.
When we put effluent or separated liquid back in off of the screw press, it doesn't produce the same bedding that it does when you use just raw manure. I think pump it back into a heavy barn or a dry cow barn, and try to separate that.
You could see some difference, yeah.
There is a difference.
We're talking about separation here, pre-digestion, I guess, if you will. Does he have anything, post-digestion?
Ken, can you speak to any post-digestion solid separation?
Post-digestion?
Post-digestion, post-anaerobic digester.
Yeah,
Solid.
sure. So when farms transition to digester, there has to be an adjustment in how we operate the separators to account for the burnup of solids, structure and size in the digester. And usually the first step is we just make or we install tighter screens in the separator to capture the smaller fiber and still have enough for bedding. In some extreme cases, the digesters are so efficient, they burn up all the fiber or most of it, where a farm does struggle to capture enough to have adequate bedding. That is, I would say, very rare, but I think 2 of them come to mind in the last 10 or 15 years where we've run into that issue. Another point to that is if we're working with raw manure, we usually say that it takes about half of your liquid to make all of your bedding, if that makes sense. And if you're digesting, that can be as high as 80 or 90% of your liquid to make enough bedding. So there certainly is a factor there of how much the digester can chew up the size and amount of fiber you have to work with.
If I can add to that a little, with the digester taking in food waste, we usually see such a high efficiency of the digestion that farms will struggle to get enough bedding.
Yeah.
They'll tend to do separation beforehand to reclaim that bedding. And I think one advantage of going after a digester is you've already got a material that's pretty well mixed, right? And so I think, Ken can speak to this more than me, but one of the real challenges is getting all your manure in one place and getting it homogenized so that the screw press can handle it, right? And even seasonally, because of cow cooling and things like that, you'll maybe have to make some adjustments to these screw presses.
Yeah, I agree.
Ken, could you talk a little more about the steps one might take to remove residual sand out of the system once you switch away from sand?
Sure. So the biggest swing you can make is right up front and removing as much sand as possible right out of the stalls and converting one group or one barn at a time. And then the residual part, what we've done is we've tried to add steps in the transfer to the separator, meaning maybe we have the utilization of an extra pit in between point A and point B. if possible. If not, we at the very least will put in some kind of sand trap in the feed system to the separator. It's amazing how well that works to have a settling drop point for the sand to fall out as it is transferred to the screw press. But at the end of the day, we're going to shorten the life of the wear components of the screw press by anywhere from 80 to 90%. Like it's the first 2 months is very costly in wear parts. That's just a reality. But after that, it seems to be pretty good.
Any other questions?
I see one here on the Q&A about somatic cell, and I didn't really touch on that too much. But overall, just briefly, I would say that udder health, cow comfort, cow health are on par or this even better than what you're on now with the right management. I can't stress that enough. You have to be willing to adjust your management. You can't just install a separator, expect everything to be the same. But I can name drop all day long the herds around the Northeast that are on solids and have been for many years, and they're 70, 80, 100,000 somatic cell, making 95 to 100 pounds of milk or more. I think bedding type is much less the conversation anymore when it comes to milk quality and cow health. I think that those who went into it early thought it was the end all be all of success with milk quality. And I think that in the last 10 years, we've learned that the parlor really has a lot more to do with that than what's in the stall, as long as there is something in the stall, as I said early in the presentation. So I'm pretty confident that with the right mentality and the right management, just like anything on your farm, it can be quite successful. And overall, the milk quality is there.
Well, I assume that to go from 25% moisture to 40% dry matter, I assume there's more associated costs in the screw press. I assume it costs more to squeeze that harder. Is that true?
Yeah, it costs more upfront. It's a specialized machine for the higher dry matter, and the real difference is once you've had that particular setup, the real difference is like from 38 to 42 in dry matter. It's amazing how it's sort of a law of diminishing returns. Once you hit up around 40% dry matter, you can really spend a lot of money just to get a couple more percent, if that makes sense. And for those that aren't really in the world of solids for bedding, 40% doesn't really sound that dry when compared to sawdust, but 40% is plenty dry when it comes to handling it. It's bulky, absorbent, it handles with the same equipment and behaves in the stall very much like sawdust at 40%. And when we've done experiments trying to get it much drier, like 50, 55%, it turns into a powder and disappears out of the stall. And again, goes back to the having bedding is more important than no bedding.
And I've seen that with years in West States, trying the solids down, they blow around the barns a lot, not stay put.
Ken, I want to thank you so much for a fantastic presentation. Ken is going to stick around until noon online. So if anybody has more questions, we can figure out how to get those to Ken. But next up is Lindsay. Can someone?
That's right. Okay, so yes, I'm Lindsay Ferlito. I'm the regional dairy specialist on the CCE North Country Regional Ag Team. And I just want to say thank you to Ken for giving my presentation for me. So Ken touched on a lot of the stuff we're going to talk about today. So full disclosure, I don't deal with manure. I deal with cows. So basically, I just wanted a chance today to make sure that we're considering the cow. Obviously, a lot of this talk is going to be about manure systems and what's happening when you're managing manure, putting it on your fields, all that other stuff. And there's a lot more qualified people in the room to talk about that. My job is focusing on the cow management. Specifically, I focus on cow comfort, lameness, animal welfare. So just as we're thinking these big picture things and we're trying to adapt and make changes for environmental regulations and greenhouse gas initiatives, We also need to be making sure that we're making the cow as comfortable or more comfortable than she is today. Animal comfort and animal regulations also aren't going to go anywhere. So we need to be maintaining that or making it better, as well as milk production. It's not good if we implement a new strategy to reduce greenhouse gas emissions, but it has a negative impact on production at the end of the day or cow longevity. So we're just going to run through some of the stuff. Like I said, we've already kind of started the discussion, so feel free to ask questions as we go to or pipe in with your experiences. Just out of curiosity, Jenny asked who was using sand. Is anyone in the room using mattresses, mats, water beds? Some, yes, okay. Exclusively or combination of some pens have those, some pens have deep beds?
We have a combination.
Okay.
We're all mattresses.
All mattresses, okay. And you guys have some of both and then some of both? Okay. On the mattresses, I know you guys are using solids. What are you guys using? Sawdust or paper?
Sawdust and paper.
Okay. And what do you guys use? Oh,
Sand and manure solid.
Okay.
In deep beds or in,
On mattresses?
on mattresses.
Okay, perfect. All right, so just quickly, what we're going to talk about, sand and manure solids bedding and the differences. And then I know that everyone hates sand, but I would argue that everyone who has to manage manure hates sand. Everyone who has to manage cows loves sand. So I'm the person that manages cows, so I love sand. Full disclosure. But like we talked about too, manure solids is a good option as well. So comparing what it means to be a deep bed versus non-deep beds and what that does for cow comfort, and then how we handle these two different types of bedding differently, and then talking a little bit more about somatic cell count, udder health, and then some of the other things in the barn that we need to consider, like ventilation and the flooring, and then just some examples at the end about making the switch. So why is sand the gold standard if you're not a person handling manure? What is it about sand that makes it awesome? Inorganic, yep. So it doesn't have the same ability to harbor pathogens the way a sawdust or a paper sludge. Yep. What else? Sorry?
Cool.
Yeah. So especially in the summer, it's cooler. It doesn't have that ability to kind of heat up the way unless there's sun beaming directly on it. Yes, traction. So it's inorganic, therefore it's been associated with better somatic cell count, better health. There's countless studies that have found higher production. And the key here, when we talk about sand, we don't say it, but we mean deep bed sand. So there are people that put sand on mattresses. You're not getting these same benefits on a mattress. The idea with sand is that we're talking about a deep bedded stall with sand. And that's when you, in multiple studies, we see reduced lameness, increased lying time, reduced hock injuries, and the idea with having traction, so we're having fewer slips and falls. And then also that can lead to changes in your culling strategies. So we usually have a better ability to cull more voluntarily because we're not having to get rid of those animals that have slipped or fallen or got banged up in a stall. So essentially, sand can kind of cover a lot of sins. You can get away with a little bit more in terms of your stall design, stocking density, bedding management when you have a deep bed sand stall. And then also too, I'm gonna like loosely use the term manure solids just to kind of generally talk about manure solids bedding. And I recognize that we could have a digested type bedding, or we could have separated that then is going through drum composters or some other drying process. Like in California, it's so dry they can just literally lay it out for a couple of weeks and then put it in the stalls, and it's like really dry dirt, or just fresh green from the separator. The challenge when we're looking at comparing sand to solids is because there's all these different types of solids, and they're all kind of done a little bit differently. It's hard to get a lot of data that specifically is looking at sand versus digested solids, sand versus composted solids. So some of the research is looking at kind of just manure solids as a whole or a specific type of solids. But for the sake of the presentation, we're going to kind of just talk about them as a general manure solids versus sand or other types of bedding. And then again, too, like we talked about, if we're talking about sand, we're thinking a deep bed. And then if we go to solids, we could either be doing the top, which is a compost pack with manure solids bedding, which those are awesome from a cow comfort perspective, hard to manage with our climate in the Northeast, but that is a picture of a New York barn. So some people are doing it, or we could just go from deep bed sand to deep bed solids, or you could talk about switching to a mattress system. So just talk about some of those, the pros and cons of each of those. So as I said, I'm a fan of sand, partly because most of our deep beds in the Northeast are sand. So basically I'm a fan of deep beds. If there's a way that we can manage a deep bed, regardless of the type of bedding it has, that's fine. So as long as we can still have that deep bed for the cow, that's what's important. And when we're talking about deep beds, we're really looking at ideally like that 6 to 8 inches of bedding in the stall, but essentially anything about more than 4 inches, so that when she steps in that stall, her hoof is not sinking through the bedding and hitting a hard surface underneath. She's stepping in, it's got that give, it's loose, it moves around, her hocks aren't rubbing against anything, she's just hitting bedding. But lameness is a huge one. On deep beds, we see lower overall lameness as well as lower severe lameness. So again, getting that cow longevity, a lot less costs going into that if you're not having to manage that lameness. Overall hock injuries, so again, thinking about the animal care requirements that we have with the FIRM program, we do have requirements for lameness and hock injuries, and coming up in July, they've added an additional lameness requirement as well. Previously, it's only focused on the severe lameness. Now there's also a total lameness component. So things that we need to be making sure that we're staying on top of and keeping track of. And with the hock injuries, deep beds just blow mattresses and mats out of the water because it's just so hard to keep bedding on a mattress that eventually her hock is gonna rub on that surface. And usually they're a little bit abrasive so that they're not slippery. So you just get that hair loss, and then over time you can get those open wounds or swelling. And what's interesting too is that deep beds can help increase or reduce the healing time of injuries. So if you happen to have an injury, if she's on a deep bed, it'll heal faster. So like in some cases of farms where we have combinations of different types of bedding, even if you can get those animals off of a mattress or a mat or a waterbed for like the 2 months that she's dry, we actually start to see those wounds healing and hair starting to regrow. So it can happen within a couple months. So anytime we can incorporate deep beds is beneficial. And then from like a comfort perspective and her resting, we see higher line time on deep beds, up to 1.5 hours a day. So when we think about lactating cows, usually are only laying down for about 11-ish hours a day. 12 hours is always the recommendation thrown about, but from multiple studies, we see that it's probably closer to 11 that they're actually laying down. So 1.5 hours a day is a huge difference between those two different types of housing systems. And again, the severe lame cows are benefiting from those deep bed systems. So they will actually lay down longer, which is better for her to heal and to rest. And then that translates into milk production. We know from other studies that about 1 hour of lying time a day is linked to anywhere from about 3.5 to some studies now are saying maybe 5.5 pounds a day. So she's resting more, she's comfortable, she's not getting injured, and that's translating to production. And then like we talked about the changes in culling. So with that in mind, we can agree that a deep bedded system is, from a cow's perspective, cow comfort perspective, having more bedding is better. That being said, we can still manage mattresses and still be successful on them. We just have to kind of take those principles of a deep bed and do our best to apply them to a mattress. So regardless of what type of system we're looking at and what type of bedding, like Ken was stressing, it really isn't so much the type of bedding as how you manage it. So bedding amount is the key. We see reduced lying times with every 1 inch reduction in bedding. So if you have a deep bed and it starts to get concave and lower below that curb, that'll reduce her lying time. And then depending on, or regardless of the system, so even on a mattress, lying time was increased when there was more bedding. So if it was greater than about 0.8 inches, then she had higher lying time and she also had less lameness. So if there's a way that you can keep more of that bedding on a mattress, that's beneficial for her. What's kind of cool about manure solids, like we were talking about how much bedding you have, and we'll talk a little bit too about the cost, but essentially once you have those systems in place, labor aside, the solids themselves are a free type of bedding. You're not purchasing it to bring in more. Whereas if you had to bed animals with sawdust or sand, most likely you're purchasing them. So this is an example on the left of a farm that is purchasing sawdust, and sawdust is expensive, and maybe you don't have the place to store it, or you didn't get your shipment this week, or you don't have the labor to put it in the stalls. So a lot of times with sawdust, we see that example on the left where she's on a mattress or a mat, and the mat's pretty exposed. So she really doesn't get the benefits of the bed. The benefit of having those manure solids is me, from an outsider, coming to your farm. I'm not trying to convince you to buy another load of sawdust just to put it in your heifer pen. But if you already have the solids and the ability to go out there and add it, this is a local farm on the right, with actually bedding their heifers. And usually that age of heifers does not get bedding. So there's definitely a benefit of, if you have this material on the farm, maybe we can actually do a little bit better of a job bedding some of those animals that should be getting more bedding. And it was also mentioned too, the differences in bedding frequency. This is a huge one, the differences between sand and solids. So if we're looking at deep beds versus non-deep beds, already when you have like mattresses or mats, you're bedding more often than if you had a deep bed. But then even if we're just looking at deep beds and then we're looking at sand versus solids, as Ken mentioned, on average, most sand herds are adding bedding about once to twice a week. So this is an example of like 325 farms in Wisconsin. Most of them were doing it once to twice a week, but then when you looked at solids, they were doing it anywhere from 5 to 7 days a week. And then specifically in this second study there, 38 farms in the Midwest that were all using solids, and the majority of them were adding it greater than 3 times a week. They then didn't break down how much higher than 3 times a week, but most of them are doing it more than 3 times a week, and then some were just doing it once or twice a week. So the big take home with bedding solids or with manure solids is that you're adding it more often in a thin layer on the top. So just adding little bits at a time every single day, or 5 days a week, 6 days a week. So we'll talk a little bit at the end. See, that's a huge change in labor in terms of how you're managing your bedding. So grooming was also mentioned. So differences potentially with sand and manure solids, but again, with the grooming, the idea is that we're keeping that stall a level, loose surface. So she wants it level with or above the curb. We don't want it decreasing. And then we also want it to stay level across. So there's actually been studies where poor grad students had to go out with little grids and measure how deep it got into different sections of the stall to see if the cows didn't like it when it started to get lumpy and bumpy. Shocker, the cows don't like it when it starts to get lumpy and bumpy. So the more we can keep it level and flat and loose is better. So with the grooming, yeah, the idea is just that we're keeping it loose, so it's not packed, and that it's level. So whether that's, I stole a picture from Meyer Dairy there, where they just have the attachment with teeth. We don't want to be going too deep, because you don't, same with sand, you really don't want to be bringing all that back up, but really with solids, we don't want to be bringing the dirtiest stuff back to the top. So depending on your system, some farms are even just getting away with having a bar. So it's not even using teeth to kind of bring it back up, but just a bar that goes out to kind of just knock down any of the lumps that have come through if you're adding it regularly, and it's being maintained. Perfect. Okay. So again, doesn't matter what we're using, the cow wants that stall to be clean. And again, they did studies to actually prove that, and they found that dirtier stalls are associated with higher lameness. So that's not surprising, because if the stall's dirty and she doesn't want to use it, she's probably just going to spend more time standing in the alleyway, standing on concrete, standing in manure, or in this case, if the stall is that dirty, eventually she might go into it, but now she's standing in wet bedding, where we're still having that moisture on her hoof, leading to lameness issues. And then also too, going with that, if we can keep our stalls cleaner, that is associated with higher milk yield. So maintaining this bedding is a lot of work, but if you can do it, the cow is going to stay more comfortable, healthier, and it's going to lead to higher production. So the big difference with manure solids is the bedding dry matter. So obviously sand is almost all dry, 90 to 95% dry matter with sand, whereas manure solids is a lot less. And studies have been done looking at what cows want from bedding in terms of moisture. And basically we know that she likes it when it's dry and she doesn't like it when it's wet. And studies have looked at kind of where that threshold is, and it's about 60%. So that's what we usually aim for. Like if you're talking about sawdust or paper sludge or some sort of organic material, we're looking for about 60% or higher for dry matter. What's different there is that manure solids aren't 60% dry matter when we're putting them in our stalls. So this is where it gets a little confusing, because cows have said that they like for stalls to be drier. But as Ken was saying, cows don't mind manure solids. They actually really like them. And I think one of the benefits of manure solids is because they're a little bit damper, they kind of clump together better and stay on the stalls. Like you guys were talking about, if it gets too dry, especially in the summer, it's impossible to keep sawdust on a mattress. But if it has a little bit of that extra moisture with the solids and it's such a soft, fluffy-ish bedding, that maybe it actually does kind of help keep it on the beds. So like there's a farm that has manure solids on water beds, and water beds are even trickier because they have like that jiggly factor that if you try to put sawdust on a water bed, as soon as the cow steps on it, it kind of just starts to fall off the water bed into the little valleys in between the stalls, which is not beneficial anyway. So having that little bit of moisture in the solids actually can kind of help stay like packed almost on the water bed. So we're getting that benefit of actually having the stall covered in bedding. What's also interesting too about manure solids is when we think about like a truckload of sawdust, like a truckload of dried sawdust, I would assume that the dry matter of that sawdust is going to be higher before you put it in the stall, where the cow is then going to be using it, maybe urinating, bringing in moisture from her hooves, maybe leaking milk. I would assume that used bedding would be lower in dry matter. But with manure solids, it's actually the opposite. So there's huge ranges depending on the study and depending on the type of solids we're talking about, but anywhere from like as low as 27% dry matter up to maybe like 55% in the unused bedding. So like measured before it gets put in the stall. And then we see slightly higher dry matter after it's been added to the stall. And that's because when we're doing it, we're adding it every day or almost every single day in that thin layer. And we'll talk about ventilation and heat abatement. But if we have good air movement in the barn, then those solids are actually drying a little bit in the stall after we've added them. So that's just kind of something that, again, the benefit of adding them more regularly, because they're going in more wet. We can't be adding a whole bunch of wet stuff all at once, because then we're not going to get that drying out factor. Lime is also something to consider, and I'm curious to hear from the farmers afterwards about their experiences with lime. It's kind of across the board what is used, how it's used, and there's not a ton of published research on this. It's very anecdotal and case studies, but basically some farms are using lime. There can be benefits. There's differences between hydrated lime, which is usually added to the stall itself, versus quick lime, which can be added incorporated in the bedding before you actually add that to the stall. It has been shown to reduce pathogen load, but it's iffy how long it actually stays effective. And a lot of studies suggest it's probably only doing it for about 24 hours. So it's recommended then that you're adding lime daily. A lot of farms that do lime don't do it daily. They might do it every other day or on the days that they don't do bedding or something like that. But there's still more work to be done there. But yeah, it looks like maybe the efficacy kind of starts to decrease after 24 hours. And then I'll just put like a huge star there that safety is a huge issue with lime, especially if you're using the quick lime. So just making sure that we're following any OSHA requirements, that we're giving our workers the proper, eyeglasses or masks or whatever. We've seen guys just walk through with like a bucket of lime and chucking on the stalls, and they're not wearing anything on their face, and they're just like white by the end of it. It's probably not great. So making sure if we're doing that we're doing it appropriately and safely. And then the hygiene is one that's interesting too, because I think, as Ken mentioned, I think there's this idea that people assume if we're bedding cows on poop, that she's going to be dirtier. But if we're doing it right, she shouldn't be dirtier. And this is the next few slides are all going to show conflicting data. But I basically just wanted to show that it depends. Like with anything we talk about with bedding or with stalls, it depends on how you manage it. So the first study there found that we did have dirtier udders on farms that were using solids compared to farms that use sand or other types of organic bedding, so like sawdust. So in that case, it seemed like the manure solids were worse in terms of hygiene. And then the next one looked at leg, flank, and udder hygiene on deep beds specifically with solids. And so looking at deep beds with manure solids, new sand, and recycled sand, and they were all pretty similar. They then found a difference when you had mattresses with manure solids. So just harder to keep them clean when you didn't have that deep bed solid. And then that last point there is from studies in the Midwest, where they basically found that the hygiene was actually better on the ones that had manure solids. So again, I think it just comes down to what farms are in those studies, how those beds are being managed. You know, that's not taking into consideration how often the bedding is being put in, how often it's being cleaned, the dry matter of it. So that's like that management factor that you can't really incorporate there fully. But basically, yeah, they can be as clean or cleaner if done properly. And then just a reminder too that FARM program is asking about hygiene. So far, it's not a actionable item, but it is being measured. Maybe that'll change. It's not going to change with 5.0, so you have at least 3 years before it would get added. But at this point, it's not being added, but it's still getting measured on your farms. So if you did make that switch, you'd have an idea from at least from your farm evaluation if you had a change. So yes, then let's talk about somatic cell count and udder health. So again, I think the idea is that with solids, we're going to have worse somatic cell counts. We're going to have more cases of mastitis and more challenges there from a milk quality perspective. Again, it varies. So that study again of all those farms in Wisconsin, and they looked at bulk milk somatic cell score, and they found it was lower on the sand herds compared to organic bedding or manure bedding. And they also found higher production with those sand herds compared to organic bedding or manure solids bedding. Another study looked at manure solids versus straw, so just a different type of organic material. So in Canada, straw is potentially a little easier to come by than it is here. And they found lower somatic cell count in those manure solids herds versus an organic material like straw. And then kind of as like a general take home when you're looking at what the differences are between these types of bedding, a lot of the studies that have been done on manure solids have been done in the Midwest, Wisconsin, Minnesota. But basically their general take home usually is when you look at like the average farm somatic cell count of manure solids herds, it's comparable to the regional average in that region. So it's not like you can look at it and be like, whoa, everyone else has, you know, 225 and all these herds are 300. It's still comparable. It still looks like an average farm. Obviously, there's variation from farm to farm, but it's not like it's an obvious thing that manure solids bedding are automatically higher somatic cell count. And again, that the main take home really is that somatic cell count is based on or driven by how clean and dry you're keeping those beds. So regardless of what you have, if you can keep it clean, with the exception too of pathogen load being organic and inorganic, but in general, if you can keep that manure solids clean and dry, then you can manage somatic cell count.
And Lindsay, isn't it also, you know, has a lot to do with the whole farm system, right?
Yes,
I mean,
exactly.
I don't know if you're headed there, but like the milking center protocols are another key piece, you know.
You kind of mentioned that the parlor issue, or, you know, how the parlor operation can affect the cell count more, and maybe more so on newer solid.
Yeah.
And maybe a little more forgiving.
Yes, exactly. Yeah, that's where again with sand, you could maybe like, oh, you didn't bed that day, you can get away with it, or your workers.
See that you can get away with it on sand.
Yeah.
For a little bit longer.
Yeah.
Than you can on yours.
Yeah, yeah, you have a little more maybe protocol drift. Some teats aren't getting cleaned fully or something. Yeah, definitely. So in addition to somatic cell count, then looking at bacteria and mastitis. In general, one study found that cows that were bedded on organic materials had higher incidence of mastitis, up to 2 times higher. But again, that farm or that study of, or sorry, a different study looking at 168 farms, and this was across 17 states, so not just the Midwest, different ranges. They basically found that there was just a lot of variation between bedding types and within bedding types. So getting back to how are you managing it, and what is your facilities, what is your management? They did find in that study that manure solids was associated with higher bedding bacteria counts and poorer udder health. But then the study looking at just those manure solids herds in the Midwest did find good udder health, but they found that it was linked to farms that had good ventilation. They had increased scraping of the backs of the stall, so basically stall maintenance, keeping those beds clean and dry, and in that case using lime, so kind of just doing extra things to help reduce that pathogen load. So basically manure solids are a higher risk bedding to be using, but it can be done with the proper management and the right tools. So I then had a chat with Paul Verkler from QOPS because I just wanted to get his perspective, given that most of our data is not coming from New York. And Ken mentioned that there's a lot of herds in New York that are doing it, not as many up here in the North Country, but definitely in Central and Western New York, and they're doing a good job. So just chatting with Paul, he basically said, yes, in summary, it is a harder thing to work with. It's a riskier thing from, just from starting, but it's totally doable with the right management. He agrees that sand can cover a lot of those, or gives you a lot of leniency, whereas manure solids do not. And he did say that some of the herds they work with in New York are managing for 100, just under 100 somatic cell count, but they are tightly managed. And he agreed the closer you get to bedding every single day, the better. That's when they see more success, is again, just putting on that thin layer every single day, keeping that bedding clean and dry. And interesting too, so like thinking about like differences in our climate in the Northeast, we obviously have humidity in the summer, which can make managing a wet bedding challenging. But we'll talk a little bit more about ventilation and heat abatement. But I think we've made improvements in our barn ventilation and our air movement in the summer that actually Paul was saying that most of the herds struggle with winter. And when they look at their, they do, the bulk tank somatic cell testing regularly, that most of the herds are having their biggest challenges in the winter. I'd be curious to hear what you guys have to say about that. He was just saying, just in terms of the ventilation that we have in the barns, and we're still putting a wet material into those stalls, but we don't necessarily have the same airflow. So it can be a challenge. The big difference is in terms of the like actual types of pathogens, and what they're seeing is strep. So he said strep can definitely be a challenge, and you can start to get chronic cows. So he said in some cases farms have made the switch. The first 6 months or so is great, but then they start to get these cows that become chronic, and somatic cell count on those specific cows just starts to creep up and get higher and higher and higher. So that just becomes something else that needs to be managed a little bit differently potentially than on clean sand. And even too, like we do with some sand, some farms do it a couple times a year or once a year, going through and just digging out the whole back of the stall and putting in fresh stuff to start over when we start to get that pathogen load buildup and that gunky, gross black sand at the bottom. And some of those farms with manure solids now we're having to go through and do that and just dig it all out of the back and start over. So again, it's a bigger challenge from an udder health perspective, but doable with the right management and the right tools. So one of those is that barn ventilation that we talked about. So like I said, some of those studies have found it, and just talking to other people and, from different case studies, if you're going to be successful with solids, your ventilation has to be on point. So you have to have those air changes per hour in the winter and in the summer, because we're adding more moisture to our system. And the whole thing with ventilation is that we're bringing in fresh air to remove those moisture and gases that the cows are producing. And then we're going to go in and bring in more moisture with the bedding. So we have to make sure that our system is designed to be able to handle that. And then in the summer that we have proper heat abatement. In the summer, the benefit there is that we have a lot more airflow at cow level. So we're getting more air movement over those beds so that when we're putting in that layer of bedding, it will dry out. As Devin mentioned, it can get too dry. So it definitely can become then a challenge where we have it just too fluffy, it's too fine, it's blowing everywhere. There's definitely been times where I've done assessments on farm and like for the next 24 hours, I'm like finding manure solids like fluff like everywhere. It's disgusting. So again, not great because it's not staying on the stalls, not enjoyable for workers. So that, yeah, can just become a challenge. If it's too dry and we have too good of heat abatement, it can just be a challenge to keep it on the stalls. But I've heard examples too in the winter when farms are adding the bedding, and sometimes they just kick on their fans that they normally would use for heat abatement for like half an hour or an hour after bedding to just try to get a little bit extra air movement over those stalls to help dry it out. So flooring and traction, like we also talked about too, is a huge issue with solids. Sand is, yes, it's abrasive and eventually it can be wearing on things, and we do get some wear on the hoofs because of it, but it's the best thing in terms of traction for the cow in those alleyways. So again, it's really hard to find data on this. I thought it would be easier to show this from a data perspective. And again, it's very anecdotal, but I think we can all agree that walking in a barn with manure solids is slipperier than walking in a barn with sand. And that a study from the Midwest found that 15% of the deaths on the farms were from injuries from slips and falls, and it was twice as high as sand. So again, just managing for the fact that you might lose more animals because of leg injuries or slips and falls than you did on sand. So reiterating the importance of grooving. I know Ken talked about textured, but just making sure at the bare minimum that we have the proper grooving in all of our alleys and our laneways. And those are the recommendations from University of Wisconsin. And then just, again, how to manage that traction issue. So animal handling really becomes important, or proper animal handling really becomes important. So making sure that if you're switching from sand to solids, that everyone that handles cows maybe gets a quick refresher on proper stockmanship, on low stress, calm, slow movements. A lot of times I do lameness scoring for farms. And so I'm literally just standing there watching cows walk home from the parlor. And the number of times the chaser starts sprinting at the end of the pen to bring that last 10, 15 cows back so they can get on track. And that's like the worst thing we can do, because those 10 or 15 cows are statistically more likely to be lame. And now we're asking them to run. And then if we do it in a flooring surface where they have no traction, it's just going to be a disaster. So making sure that people really understand the importance of slowing down, not stressing out those cows. Oh, perfect. Okay, good. And then human safety too. An interesting fact I came across when I was looking into slips and falls on farms is that most of the causes of injuries on farm isn't to do with machinery or other things like that. It's cattle. And then the second is slips and falls. So it's also an issue for your people, especially if a cow is slipping and falling. It's harder for me to say if the floor is slippery, or I could slip and fall. So just in general, making sure people are aware of how the floor is going to feel differently and how the cows are going to move. And then obviously heat detection. If animals know they don't have good footing and she slipped and fallen before, she's less likely to show those heat signs again, because she doesn't want to slip and fall again. So what does your repro system look like? How are you managing or measuring heats? And just recognizing you might not get as strong of those mounting and standing behaviors if she's going to slip and fall. So I just have a few more slides. This one is really cool. This is a farm that actually doesn't use manure solids. They use sand, but they still came up with this idea, and I apologize, it's really small, but basically this is their freestyle barn, parlor, holding area, and then these are their various pens. And they felt like they were getting rid of more animals, basically more involuntary culling and injuries and death than they wanted. So they picked the three main causes. White is injuries, yellow is something else, and then pink was mastitis, I think. And they basically, every time they had an issue, they went to the corkboard and pinned it. And then they just tracked this over a few months and started to see like, what is going on in these pens, or that's parlor, but what's going on in pen 4? Like what's going on in pen 8 and pen 5 that we're having all these injuries that we're not having in these other pens. So it might be kind of a fun thing to do if you switch to solids, and just kind of track, are animals getting injured more? Where are they getting injured? Maybe in this case, it was, I think, a facility thing, or that pen was more crowded or something and animals were slipping and falling, but just seeing, are we having trends of more animals getting injured? Where are they getting injured? Can we go back and retrain or fix something in that pen to prevent it from happening? I'm going to gloss over this one really quick. Obviously, there's differences like Jenny talked about. We're purchasing sand. That's a huge expense. And there's huge expenses with the wear and tear on your machinery. With solids, there's going to be an investment in some sort of system to start with. But then after that, we kind of have this readily available free bedding. The big difference is labor. So those farms that went from adding bedding once or twice a week, and now you're adding it 6 or 7 days a week, farms have talked about literally having to have a full person whose only job it is literally adding bedding for hours and hours a day. So just factoring that in, those prices are all going to be different in every farm, but just recognizing you're going to need more labor. You're going to need more manpower to get that done, and more wear and tear on your bedding system, whether it's a skid steer or some sort of tractor shooter. Are your people good at driving up and down your alleys every day, or do your barn doors get banged up? So maybe just quick on skid steer safety or tractor safety. And then also the benefits of if you have less of that material that you would then have to handle. So that's a benefit too. But yeah, so there's definitely pros and cons. Either one can work. My last slide is busy, apologize. But, and we'll hear from tree farmers today. And that's, like Ken said, that's the best. Talk to people that have done it, find out what they did, find out what they don't like, find out what they would change, and then tailor your approach differently. But this, as I was doing research on this a little bit more, I came across this a podcast with Jeremy Natsky from Wisconsin. And basically he transitioned, I think it's like a 3,000 cow dairy from sand to manure solids. So as Ken mentioned too, like doing it slowly. So over like a 2-month period, they did 1 pen in each barn at a time. So they did it in this barn and then figured out, well, that didn't work well. Okay, so then we tried it in this barn that maybe has a different alley system or something. So every time they did it, they tweaked things and made it a little better instead of just diving in and trying to change everything at once. And he did talk about the importance of leveling. They actually had to go and get a local dealer or mechanic or something designed like a custom leveler for them with the right amount of teeth, right depth to fit into their stalls appropriately. He did talk about slipperiness becoming an issue, so they had to go back in and just regroove their floors to make sure that they were just getting the best they could out of that grooving. And then they're only bedding 3 times a week. And then on the off days, they're leveling and liming. So that works for them. But like I said, some of the other studies have shown that maybe you need to be bedding more often. And he said, it's just a fact, you're gonna have more mastitis. But he's happy with where they're at. He said they're averaging about 120 cement XL. Oh, sorry, that was on sand. They're about 150 on solid. So not like a crazy difference. And what's interesting, and I know Ken mentioned this too, was really getting the people on board. So he talked about having monthly milker meetings. So it wasn't something they just changed. They really kind of phased it in, made sure that the entire milking staff, that the whole barn staff was on board with it, understood how it was different. And then they regularly monitor things like dry matter and looking at those pathogens and udder health. So making sure that people are aware of what's going on, how it's going to be different, getting that buy-in from the staff to really be successful. And he said it's going to be a marathon, not a sprint, and ask questions. So yeah, basically deep beds are better from a cow comfort perspective, production perspective, anything where we can just give her more bedding. And again, the type of bedding isn't really the biggest factor. The biggest factor is, can you keep that bedding in the stall? Is there enough of it? Is it dry? Is it clean? And then, yeah, it can be a bigger challenge, but if you do your homework, then it can totally be doable.
The one thing that hasn't been mentioned by either of you is stall size and configuration. And that's gotta be right, no matter what you're doing.
Yes. Yeah, thank you. Definitely. Yeah. So, and that's where, like, again, you can kind of get away with some things with sand a little bit more. If your stalls aren't perfect or if they're smaller, but they're still more comfortable because you have a deep bed system. Yeah, you can get away a little bit more with having a not properly designed stall. But definitely we could go down a whole other section too of stall design in terms of udder health too. Like that's a huge trade-off is, like Paul and I had that discussion with like brisket boards or neck rails. Anything we're doing to the stall is to make our life easier. We don't want her to have free range of that stall because then she'll make it messy and dirty and then we have to manage it. But from the cow's perspective, we want to give her more space. So yeah, definitely too with like a somatic cell issues and stuff. Maybe you do need to do some tweaking to your stalls and because depending on your stall design, your stalls might be getting messier, or maybe you have to do a better job of keeping more bedding in because your stalls are too small or something.
You also see the stocking density on the deep bedded sand versus the mattress with sand on top of it. We can run a higher stocking density and get higher laying time. We can get higher laying times with a higher stocking density on the deep bed.
Yeah, it just like and I'm not kind of like poo-poo mattresses because you definitely can have all the top outcomes on mattresses. It's just so much harder because you can't maintain that bedding. And like at NEDPA this year, Novus they showed like their top 15 producing herds or 10 producing herds. One of them is a mattress herd, like across the country, because it's just, deep beds are just already starting up here. So yeah.
There any increases that people that use the bedding, solid bedding in rodents, birds, flies?
I could show you a video of me lameness scoring in a pen when I made a couple friends. I don't know if I'd like to hear from the people that have switched from sand to solids. I would assume because it's a pretty sweet, cozy little place. And like I said, yeah, I've made more friends on manure solids farms than sand. But yeah, that's a good question for the farmers.
You switch from manure solids back to sand or to sand, and we still have I mean, that was
Yeah, hasn't increased, no.
They just don't live in the stalls, they live somewhere else. Like,
Now, if you let the cows stick the manure solids out of the edge of the barn into the drip edge of the, the barn roof, then you create habitat for the flies, right? So I think there's management there is again key.
But the sand goes right out.
But this, yeah, exactly, yeah.
When we had manure solids outside, we got a lot, we were gonna get worms, and we wanted to go fishing, with the sand out there, it's not as many work.
that's an added cost.
Decrease in sales.
Any more questions for Lindsay? Okay, we are now going to launch into 3 different farm perspectives. John, do you want to come up and present first? We'll hear from John, who will talk about his experience from Patterson Farm. And then we'll hear from Dale Stein and then from Doug Shelmidine. Right, just 3 perspectives, and maybe we'll save questions and answers to the end, so all 3 of them answer. We're just gonna sort of speed round through them.
Okay, so I'm just telling you, not right or wrong, this is just what we do. This lagoon out here is a sand lagoon today. It used to be when we separated solids and bedded everything with manure solids, it was the second stage for, we mechanically separated, then the manure would go into the first stage. And basically we ran out of storage and built another one at home. And that was a 2-stage lagoon. So when we took the solids out and got into very dilute 1 or 2% solids in that second stage, we had a lot more foaming when we went to put that in trucks and a lot more trouble keeping it in the field. But that's the home. So today we've got 1,800 cows on I think all the lactating cows are on sand. No, 450 cows are on Syracuse fiber. So the original barn over here, there's 450 in there that are on beet bedded manure solids or Syracuse fiber. We one day a week we bed with Syracuse fiber. 1 day a week we use manure solids. So when we started out, we had mattresses and then Syracuse fiber or sawdust on it. We had a lot of raw hocks, didn't like that. I really hated replacing the mattress covers. And we also had alley creepers running 24/7 at that time. And then in '99, we wanted to put in manure storage. So I didn't want to just put a pit in the ground and store raw manure like people have been doing for years. So we put in a separation system out here, and then we pumped the raw manure from the dairy barn over to the separator and separated the solids, put the effluent into the heifer barn to make the heifer manure separate pumpable, so we could pump that, separated that when we could. That's where we ran into the heifer manure with the effluent off the screw press didn't make as nice a bedding as the raw manure out of the dairy barn. So we put in a composting facility when we did that. So we put in a static aerated composting pile. We had the cows were on mattresses that seemed to work good. We had lots of bedding because we had invested capital to make the bedding instead of buying sawdust. So we were able to load the stalls up, but I really didn't like the maintenance of the mattresses. So we had converted that barn to deep beds also, but we still ran a 200,000 cell count and 35% call rate probably. So when we took the manure solids and made a pile, we had it'll heat up great. It's great for composting cows or calves or mortalities or anything like that. It just heats up so fast. But what we did originally, we have a floor under here with fans that blew air up into it, and we had those all on timers to help aid the composting process. So like just showing that that stuff heats up great. Then we built a barn in 2001, and that barn was all deep beds, and we put manure solids in there, and we had trouble, I was not a great cow person, I can manage equipment, but we really struggle with mastitis on, and mastitis management in our deep bedded system. So, we had our mastitis rate, went from 2003, went up from 9% to 16%. Then we put in a digester in 2005. We saw that the composting process really did a great job of getting rid of the odors in the solid portion. So we thought that digestion would help that for the liquid portion. And we didn't want to just build a digester without way to have it make some money. So we put in a complete mixed digester that would bring food waste in. That made it almost impossible to separate the post-digested solids and get enough bedding to deep bed cows. So we stopped doing that, separated raw manure before the digester and bedded with that. That helped us do a better job keeping bedding, like Lindsay's saying, in the stalls more because we had more of it. When we were bedding with manure solids, we were bedding every day and grooming every day, or we even got to where we were grooming 3 times a day. Still struggling with our cell count. We had a very intense procedure in the parlor and still struggled with it. And we had a quite high cull rate. When we got to bedding with manure solids green, we tried putting quicklime with it. That seemed to help during the dry season. If we could keep the quicklime dry, but it was a fire hazard and a health hazard the way we were handling it. So we went away from that. But that digestion process really eating up a lot of the solids was very challenging. So we went to 2018, cell counts at 500,000 and really in a 40% cull rate, trying to figure out what to do. So we decided we'd try sand. We put sand in one group, and then we've continually went switching more and more groups to sand. And we put a vacuum truck on to start vacuuming the manure. And then now we've got, like I said, 1,200 cows on sand. That all goes to one storage. The original barn goes through the separator for the manure solid separation system and what used to be the digester. So now with the sand bedding, the cow comfort, I was just looking. So we've got a group of cows that's got, we have AFI meters so we can tell how many hours a day the cows spend lying. So we've got, a group with higher stocking density and deep beds. We can run, they've got higher hours of resting time per day than the group that's on mattresses with sand on top of it. We've got a lower cell count. We're about 150,000 right now. That's about the high of where we want to be. We're cleaning the back of the stalls out now. We've been running a 25% cull rate for the last 5 years. I think it's up because we just ran out of room and can't to keep animals. And definitely the slipping and falling is much less on sand, but we still have to groove floors and take care of that. The sand is extremely hard to pump in the manure system. There's no doubt about that. We've got 4 pumps, 4 or 500 horsepower pumps, and we'll pump the sand manure for 4 miles. But we can do it. We inject it. We don't truck any manure from the sand if we can help it. So I think Ken hit on it, but I think it's very important that we pay attention to when we're dealing with separated liquids in a storage. It's not the same manure that we're used to with sand or with raw fiber, and we need to make sure that we're incorporating it. So this is just us pulling an air rate to try to poke holes to keep that stuff from running off the field. We don't want to end up with more water quality issues because we are trying to help lower our carbon intensity score. I think it's important that we are pay attention to what we're doing. This is just another tool for drag hosing to incorporate that liquid manure because it moves so much faster. We do a lot of injection. And then, sand boating, we do quite a bit of that. And then, what you run into is trouble with the sand and plugging up the pipes. If we don't keep it moving fast enough, but we find that our cows and are performing better, our cull rate is down, and I think our whole carbon intensity score is down because we've got 60% heifers to cows ratio because we don't have, we're not culling many cows. We don't have to raise as many heifers. So I think that there's a way to make the people who can manage cows can make this manure solid bedding work. I was not able to, and so we've gone in this route. I think I hit on all that. So we're going to host the Manure Expo this year in July at our farm. So come on out and see what we're doing out there.
All right, we're between about 1,100 cows. 3 times a day, 85 pounds a cow, 4 or 5 fat, 3-5 protein, 85,000 annual somatic cell, all solids. Have been since 2012. We are bedding about 1,200 animals are going through the separators, 2 separators every day. We're bedding 1,400 free stalls and 2 packed barns with 250 young stock in. And we have enough bedding to bed all that. We're bedding Monday, Wednesday, Friday, the solids, with just a side shooter. We are hand raking stalls once a day, or not once a day. Every time they scrape when the cows are milked 3 times a day. They're just walking through with a hand rake, pulling out the wet stuff or manure. We groom and we're bed Monday, Wednesday, Friday. We groom the stalls with a hydraulic bar with teeth on it every Thursday. And it just pulls out, levels them off and pulls out as much as you can. So you don't have massive amount left over. We used to be deep stalls. Go back a second. We bedded with everything. And bed mattresses, sawdust, sand, everything you can think of. And we went to solids. And for ours, it's the best we've ever had. We are deep stalls, but semi-deep stalls. We pulled 10 years ago, went in the barns, pulled them out, dug them out, cemented them into a bathtub shape. So they're deep, but solid concrete at the bottom. We don't get any of the black crap down deep anymore, which I always felt bacteria was coming up through by doing that. The cows, you go in, once we went to solids, you don't see any perching in the free stalls. They go in and lay right down. They're very soft. And a key to that is keeping them smooth and level. Every Thursday, grooming them all. We have 2 storages, a main storage at the farm. We put cover and flare on in 2012, but the separation the year before that. Just see, this is down on, we have 2 pits located on the facility with underground piping to our main storage. And this is just the barns coming up through, and this pit's being pumped in. It comes out a belt, that's not there anymore. It's now a 12-inch auger. We used to hand lime all the stalls every time we bedded, 3 times a week with hydrated lime. We add quick lime on an automatic system now. It's all mixed in the auger and goes out into the building where the storages are kept. And we felt the quick lime is definitely improved our situation with somatic cell. It heats up faster than it did beforehand. We tested the manure and had 0 bacteria in it 24 hours after into the building. You can see how hot it gets. That building is now gone because storm, the hoop blew off. We put a huge building right over the top of it. We bed free stalls right 24 hours after it goes in there. The solids, the young stock bedding will be bedded green manure, not even wait 24 hours. We bed right green, but all the milking cows will wait 24 hours. So it gets heated up. Just the exit pipe for the gas to go out over to the flare. We put that in case we ever wanted to get, our main lagoon was 9 feet deep on one end, 13 feet on the other. That was right in the bottom in case we had to get down right in and suck it out dry. It was put in 2012. There are no solids in it. We lump it out right to the bottom. In 12 years, not a bit of solids in the storage. We add a bacteria in monthly at the storage tank before it's pumped in that breaks up the solids. So whatever left after separation, so we don't get any separation in. These are welds on the cover where they weld fleeces together with their welder, the water on it. 2 pump lines come down in, 1 on each side, 5 horsepower pumps. And you just on timers, when you get the fair amount in, you just hose comes in, pumps it out, goes underground out to a 1 million gallon storage. the entire 12-acre farm facility, we collect all precipitation, all snow melt, runoff, water, rain, high flow, low flow, it all goes in that storage. It's pumped underground 6,000 feet to a 6 million gallon storage that we then have a 1,500-foot center pivot on, and we irrigate it all summer. And we've done that 4 years now. That irrigated ground has averaged 11 ton to the acre higher corn silage than the non-irrigated ground every year. So just water. We're in an area where we get less water. We're below Lake Ontario's effect and above Lake Erie's effect. We tend to have dry summers. The flare on the main lagoon, that's 2.5 feet in diameter, 15 feet tall. It'll turn on in 1st of July, automatic. It'll run at 1,700 degrees Celsius until November, just screaming. There's a lot of gas comes off these storages. Not sure if that's the end of mine, that's fine. Anyway, Smed Excel, what we do also, we run the Max Tech bolus system, which is, that's the center pivot and the back one. That's the new storage before the cover went on it. We had built the storage and 2 years later put a cover on it. The total project with NRCS and Soil and Water working together. Bottom liner in the bottom, even though it would pass the soil with the clay in it, NRCS wanted a liner in because they were cost sharing it. So we said, that's fine, whatever you want. So we put the liner in, we then put the cover on top. We had $600,000 into that storage, 4.5 million gallons, but 3/4 covered by cost share. Center pivot off of it, 1,500-foot center pivot, right across from the, I'm not sure if it's in here, the photo, probably not. Don't matter. Right at 100 feet from the storage, we have a 6 million gallon pond that we built just for water storage for collecting our facility and irrigating. And that's pumped off that center pivot. We run Max Check boluses, which is $3.30 a cow per month. It gives you the health alert on the cow, tells you what it's doing. It goes into the bottom of her belly. It's battery operated, and they guarantee it'll last 6 years. If it quits, they'll give you a new one. They'll give you free to replace it. Tells us all the health parameters of the cow. Tells us when to breed them. Tells them when they're gonna come down with mastitis, beginning to. It'll be preclinical. We get a list every single morning of cows where their temperature is up a little bit and the rumination is down a little bit. We'll pull them out. Once it's got like a 17-day window of tracking that cow, it can give you the level of the parameters of what it's doing. And if she's off that, it'll tell you right away. So we pull those cows out, check them for health issues. If we can't find anything besides mastitis, then all we do is put them on a regimen of Poron Banamine on their back and oxytocin. We have a separate milking parlor for our hospital barns, so we're not treating very many cows with antibiotics. A couple of days of that, they're right back to normal, put them back out again. And so we reduce mastitis antibiotic use dramatically. We are treating severe cows, but only if not all severe cows. A lot of severe cows we just call. Chronic cows we call. Minor cows we're treating with a regimen that's not a lot of, no antibiotics. And that right there has brought our sematic cell count down from the area of 120 down to 85 by running them boluses. Now, prior to that, we were running 120,000 sematic cell count average for the year. When we went from sawdust, we were 170, we went to 250 and stayed there for a number of years, even with the regimen that we had of more intensive stall use. And then over managing the milking parlor and how you pulled cows out and everything brought that sematic cell count down every single year incrementally lower. We'd be 85 for the year, but we're 70 in the winter, 90 in the summer.
I want to apologize because our whole committee all thought we had all spoken to Doug about making a presentation and none of us.
Nobody spoke to me other than to make the commitment to be here. So I don't have slides. I'm too close to home to lie to you. So we've been through a number of things over the years. Basically in 2005, we looked at the challenges with obtaining bedding. We were having difficulty getting bedding. At that time, we were using Syracuse fiber and there were some irregularities in availability of it. Energy costs were up at that point. So we've embarked on building a digester and a solid separation system where we use the rotary drum composter. We actually started bedding with solids off the rotary drum composter in 2007. And then we had mattresses on everything. We limitedly use solids on top of it instead of the paper sludge. I won't say it's perfect. We didn't want to deal with sand from the time we started with freestalls just because of difficulty in handling the manure. We have always struggled with somatic cell not being where we'd like it. We run plus or minus 200,000, most of the time 200 plus. And we've had our share of issues with serious mastitis issues. I'm not blaming that on solids. I think we've got a lot of things to work on and that sort of thing. In 2012 or not, no, 2009, after we started the digester, we had built a 3.5 million gallon storage. We covered that storage. We had always put separated solids into that, or separated liquids into that storage. We've never cleaned it out. To this day, the cover is still on. We pump the water off the top of it and it just goes in the little stream that runs through the farmstead. Never had any issues with that. At the time we covered it, we were hauling with smaller spreaders, but I kind of calculated that we would spend almost 2 weeks hauling the amount of water that landed on the top of that storage just to get rid of the rainwater. And so that was a big motivation for covering it. In 2012, we had gained some cows. We were still going through the digester with the majority of our manure, but the digester was actually too small to handle all of the manure and be able to maintain the temperature in it. So we put in a secondary separator to where we could bypass some of the manure. When we did the digester project, we did something different. Most people, if they were including separation, were doing it post-digestion. We did it prior to digestion with the rotary drum composter. The manure solids that came out of the rotary drum composter were very low in pathogens, but you got to remember with manure solids, and I don't know how well the quicklime works. We've never done that. We've always been too concerned about fire hazard to really try that. But any of these manure solids, once you put them in a stall and the cow starts walking in there, you've got a perfect medium for bacterial growth. So you've got to always keep the solids moving up through the stalls. We've not always bedded every day. We have moved to that recently in an effort to try to improve our mastitis and cell count issues. Beyond that, I guess one of the things with the cover, when we were running the digester, so the manure was going into that storage more, we had a huge amount of gas under that cover. Since we're not running the digester, we don't get nearly the amount of gas under the cover. Summers, we don't maintain a lot of manure stored. We just top dress on our hay fields, that sort of thing, to try to minimize the stored manure. So, but we've had a real challenge with the flare. Maintaining the flare, we've not been able to do. So that's something we've got to work on. My son Devin's over there. He's the one with the experience of pumping the manure. So if you've got questions, we also run a custom farming business where we do a lot of drag hosing for others. Many of you in the room we've done for. He can tell you the stories about sand versus the separated manure. So I guess ask for questions.
Will John and Dale come up? Questions from the room for our three implementers, not me.
Yeah, that's go with him. Are you planning on staying with Sam?
That's what the cost does.
Okay.
It keeps going up, so we're looking at sand separation, or that's the reason we're putting manure solids back under lactating cows again, is that trying to the cost of sand's gotten quite high, but if we can't maintain cow health, then I don't think we will continue with it. If I could figure out how to get cheap sand or goes a big capital cost, we'd stick with sand.
Can I ask you guys to move closer to the other comments?
No, you're not using the digester anymore.
No, we did run the digester for about 10 years. We had a malfunction in the system where the engine overheated and melted down. We rebuilt it, and then we ran it for another 2 years. In that time period, it became very obvious that our controls for the system were obsolete. There were some microprocessors, one that failed. The only place we could get that was on eBay. So when we attempted to put in some fail safes to shut the engine down before it went to the point of melting down the way it did, and they were never able to make those work. So when that happened 2 years after the initial period, cost of electricity at that point was about 3 cents a kilowatt hour, and with the obsolete controls, we didn't choose to refurbish it and move forward with it. So all of the manure bypassed around the digester. One thing I would say from our experience is, if you're going to build a manure system, anytime you consolidate manure, either have, I think Ken mentioned it, and I would agree with everything that Ken said. I didn't disagree with anything he said. He did a great job. That either have where you build your consolidation pit, collection pit before separation, make sure you can get at that to clean that out with a vac truck, or some empty it and then bucket it out. Because we never use sand, but both our digester and the collection pit, we had the digester at one point, we had sand around the outside of it because it was a complete mixed digester where we were mixing inside it. It was about 8 feet tall on the outside edge, and it just coned into the center. And so you get a lot of grit, you get a lot of ear tags, you get hoof blocks, all that good stuff. And if you can figure out a way to get that to settle out before you start trying to put it through a pump, you'll be a heck of a lot better off.
I will tell you on milking. John had said that milking procedure he felt was a huge impact. About 10 plus years ago, a man named Jeff Wiseman came into New York, Western New York, and about 20 farms got together in Wyoming County, and he said he knows how to get your somatic cell count down to 100,000 by a simplified milking system. No automatic takeoffs, no loops and hoses, no type of bend and hose or milk and slug, extra vacuum, no variable speed, a specific type of pulsation. Every farm went to it over about a 3-year period that was there, and a lot of the big ones in Wyoming County went. Everybody had a minimum 100,000 drop in somatic cell. That's what took us from 250 down to 140. And we stayed at the 140 until we got into the other things. We added on the bolus and other things to get us way down lower. The milking system, without a doubt, in my view, is, I don't care what you use it for bedding, it's your biggest issue for mastitis. If you can get, his belief was if you had any slug at all in any milk line, you had mastitis. Make sure everything was sloped so the milk left that cow and never stopped. And had plenty of vacuum reserves so that vacuum never fluctuated. And it worked.
I got a question, Dana. Using all the different beddings you've used now back in manure solids, do you think you've had an increased management to do that, or do you think
Increase in management?
Yeah, just oversight and work,
Oh, you definitely had to improve management with solids. But it's the most comfortable thing out there. We use sand for years, and sand can be cold in the winter. The solids are not. We didn't have the barns we do now we got all insulated barns and climate controlled way better than we did then. Barns could get cold back when we used sand, and the stalls could be cold. That's not the case now. Everything's more climate controlled, way better. Total different facility than we had back then.
I think the things that we really struggle with as much as anything managing the solids is also the slips on the floors. The floors is a big part of that's gonna be the biggest adjustment from somebody going from sand
Yeah.
to solids. Yes, you have to manage your stalls differently, but the floors and the cow movement is a big thing that you may not think about right up front.
We have our own groover, and we scabble floors when we need to. We haven't done it in a bunch of years, but we went through all the facility. Any type of slope floor, we bed with 6 inches of solids. The slope floors, we go in and scrape them clean once a week and put 6 inches of solids on, make a phenomenal walkway. Cows love it. And then we just clean them out once a week and put more 6 inches solids down. We got unlimited supply.
Yeah, do you think your modified beds has helped?
Yeah, in my view, it did. You had that black layer when you were really deep, especially down if you get gravel at the bottom. And we were the same way, went in and dig them all out. And then we said, this has got to be a better way. So we went in and they're still 9-10 inches probably, but it's built like a bathtub, round and up on the end, and then fill it right up. It's soft. Cows love it. We have 0 hock issues. We haven't got a swollen hock. Every hock is hairy. It's not like we had mattresses, all the hocks were bald, and you'd have a few hock injuries from the grit rubbing on them.
Have you had any trouble with your flare at all? You have probably more modern flare.
Our flare, the computer is in the deal at the manufacturer getting fixed, but we manually light it. The flare itself has had no problem, but the computer, after 10 years, died. It was all solar operated and cell phone operated. They could run it from South Carolina, and it tracked everything. But the main computer, eventually it being outdoors all the time, I think. They haven't got it back to us yet, but we manually light it on the home one. And the new one has only been a year and a half old. That's still worked great yet, but that's empty mode. So it's not going to make much gas anyway. But we're making less gas than we historically did. We're now cover crop or double cropping 550 acres. So we do a lot of spreading in the summer for sorghum and other crops. All our young stock are really fed double crops. We harvest 7,000 ton a year of double crop forage. It goes with the young stock, and we do a lot of manure spreading in the summer. That's why we went to the bacteria in the manure. It eliminated all the real offensive smell. It's not anywhere, you still got manure smell, but nothing like the liquid manure normally does.
Which product are you using?
Offhand, I can't even tell you.
Dale, can you talk a little bit more about manually lighting your flares? I think you're maybe downplaying that piece of it, right? I mean, my understanding from Ray is that as he does that manually, he actually lays on the ground to try and.
Well, the ignition is right low to the ground, so he's got to put a long probe in to manually light it. It's not like just stepping into the button or something. So yeah, it's a pain in the ass, but it's you light it once in July and it's done till the next July because it never shuts off. It just rips. And then we're trying to find now a way to utilize that heat. My brother's got it worked out on putting a stainless steel boiler in to heat all the hot water for the parlor. Through the summer, we know we got plenty of gas to do that, but it's not on the front of our burner to get done.
So do you have a valve to shut off before it goes out? Like
Yeah, you can shut it right off if you want, and you just store it all and gather it all is what we would do.
All the gas we just during the week, are you doing credits or whatever, sometime now looking to trade those or?
Not yet. We looked into it when we first put it in, but at that time it wasn't worth considering. I'm not sure right now if it is or not.
Doug, did you ever explore carbon credits for your cover and flare?
I explored them for both the digester and the cover and flare, and being at around 800 cows at that point, we were too small. The verification cost would have been more than the value of the credits because, as was said, they've got to be verifiable and
That was 10 years ago, though. So
Yeah.
Yeah.
Not exactly, from what I understand.
Okay.
Because there's you've got to work with a consultant to basically market that carbon, right? And then there's a third party process that needs to take place. And so everybody's taken some cream off as that process happens. And so I know one farm was getting like a few $1,000s a year. Didn't really seem worth all the effort.
We did it for, we initially tried it back when the Chicago Climate Exchange was still going, and maybe for a year we were able to with the digester, and then that fell apart, and then we got into the car program where we were selling them for, I think we did it for 5 years or so, but as the digester was needing reinvest, and we put more cows on sand, we took cows off of the digester and got down to where we had only 400 cows going into the digester, and they wouldn't, the company that we were working with to help market the carbon didn't want to mess with it anymore.
Yeah.
That all said, right, I mean, these are regulated marketplaces, and I think the global makers, right, have made their kind of climate pledges, and so there might be renewed opportunity for these voluntary markets, right? And so that's where you really need to get together, you know, with your neighbors and through your co-ops and try and, you know, put together your portfolio of carbon reductions and see if you can get these big milk buyers to buy that. And there's a real incentive for them because keeping that value of the milk is how they're going to really account for a carbon reduction, right? When you offset that carbon to another entity, to, you know, an entity, a buyer in California that's maybe trying to offset their jet fuel, you pull that value away from your milk, right? So that also pulls that value away from these milk buyers, that opportunity for them.
When you do, if you do a cover and flare, you got 12 months to get it registered for that. We did the new one. The old one, they won't accept an old one.
Yeah.
Yeah, that's part of the challenge. You get the baseline, you get paid for the difference in what you're doing, and a lot of us installed them pretty early on, and
Like when we did it for the dairy, we had the complete mixed digester like Doug's, and we could only get it on the cow portion of the gas that we produced, you know, so we were only able to get carbon credits on the 1,100 cows, not on all the gas we produced.
well, and early on, those digesters, they sort of took some of those credits themselves. As part of, in exchange for some grant funding, they took the.
And I'm not sure I said, but we get 3 clinical cases through the milking parlor a week on 900 cows going through the parlor. They check, they strip on every cow. They find 3 a week. We're catching them all before they get there.
Bill, can you talk a little bit about how long it took you to move from sand bedding to separated solid bedding on the farm?
We started with a 5-year window. We planned with grants to do a separation at first and get all the tanks built, the pipes built. You got to bury pipes and everything to bring all the different facility barns around. We're not one barn. So it took planning and basically a 5-year window. Once we had separation all down, then we started with the cover and flare.
And can you also speak to your acquiring the climate resilient farming grant funding, cost share, or the NRCS? Like, what are some of the struggles?
You got, there's a lot of cost sharing available, both federal and state. Doesn't mean you'll get approved because of the application process, and it goes by who gets scored the highest and make everything, but you don't get approved 1 year, you apply, you know, maybe change it a little bit with soil and water, or if you have to make it a little better, so you get scored better and reapply next year. We have done everything with cost share. It's, we just keep applying. My brother's got 5 grant applications in this year.
And can you speak as the chair of the Soil and Water Conservation Committee? Like, what do you see happening in your committee in terms of thinking forward on these topics for the state?
The issue is going to be, if you sit, in my view, I can't say it's an official position, but it's a position that I believe if you don't work on it, you're going to have it rammed down your throat in this state and time. So you better start working on it while you can at your ability to do it. And I'm talking about covers and flares or digesters, whatever you want to do. they're gonna come after you in time. I think the state may delay their 2030 and 2050 positions, but I still think they're gonna eventually push it. And there's a lot in this state trying to influence our legislature to put everybody in here out of business. And that is a fact. And they do not want dairy farmers operating, especially all of us that are bigger. So you want to get your position like John that works so hard in the watershed he's in, you've gotta.
Yeah, I think we all need to keep working towards, I'd love to see more digesters and more of the buses in New York City running on gas produced from upstate New York farms. And we've already got the infrastructure in place to handle that. If the state can get on board with understanding that has a great potential to stop the use of fossil fuel that is not regeneratable, the opportunity would be great and people could see the value of it. I don't know that it'll ever happen, but I think that we need to continue to strive to do a better job. And I think that as more people do their carbon intensity scoring, I think the more pounds of human nutrition you can produce with this and low calorie and less effort, all those things have a lot to play into it. Probably as much or more than whether you get solids in your lagoon.
Yeah. I think you got to be looking ahead if you want your farm to fund in the generations to come. And my son, niece, and nephew now run the farm. I'm basically retired. My brother's still there working. They're same mindset. Get set so that we got it done before they tell you have to do it. And every farm's different. You got to figure out what you can and can't do.
So I tracked 3 things that you talked about. You talked about the irrigation increasing your yield from the separated liquids. You talked about not paying for the sand bedding, and what was the third one?
Well, yeah, we got 1.2 million gallons less manure you haul because no precipitation in it. Your manure is a higher nutrient level, so we don't have to put on as much per acre. We cover more acres. We do about 70% of our manure by drag line, the rest by 2 tractor trailers, 5.5 miles from the farm, and knifed in of that too. Everything's knifed in.
There are definitely challenges with hauling and handling separated liquid manure. Can touch on it a little bit, but we use a custom hauler sometimes, and we're the only ones that have the problem because it's separated, but his trucks leak all the time.
Yeah.
It's a challenge to keep your trucks not leaking. I love it to pump it because it's so much easier to pump, but there are challenges with it from transporting on that side of things. One of you mentioned foaming, that's a big issue with separated manure. So it's not all easier. There's easier challenges to handle, in my opinion, but there are things you have to adjust to separated manure too.
It's all, man, you can manage around any of it, but you got to be aware of it. As we reduce tillage and we increase the water infiltration rate, we are going to also increase the rate that those separated liquids or without solids are going to get to tiles or other things. So it's all, I just want everybody who's thinking about separation, it's not the same animals or manure that you're dealing with, and there's going to be other issues. And because of the CAFO permit that we're in, or we've gotten to, it's very critical that not everybody learns the same thing over and over again, because we're all going to get regulated heavier and heavier if we keep having water quality issues.
So I'm just curious, what was the most cost effective, like all the practices we talked about today from the 3 of you, what has been the most cost effective change in practice that you've done? Either you increase yield or you decrease costs for them. Do you think?
Well, I think probably the move away from buying bedding so that you have a kind of closed loop system where you don't bring that additional materials back onto the farm was one of the early big wins for us. I think the other big win for us has been doing more drag hosing, even though we've stored manure. We put our first storage up in 1978. And so we've always stored manure and seen that as a real nutrient that we can utilize on our crop. We've always tried to apply it timely and keep it in place. And I think that is still an opportunity that people need to take advantage of.
All that, plus when we went on solids, we went up 10 pounds a cow a day to just short of 90 cow comfort. And that was hugely profitable.
I would say going to sand from manure solids. I mean, we're making more milk than we've ever made in work pounds components, and we fight with pumping manure, and with a low call rate and happy cows, we can make a lot of milk, and that's what we're in the business is doing. I've tried all these other things, but I think is the best thing, but I can.
But you'd have to admit, you've changed a lot of other management things since in that time frame.
Absolutely, and that's why we're trying.
From facilities to management,
Yep, but I think that there's a lot.
So are you still running the digester even with, that's over?
It's done.
Okay.
No,
Do you have any interest in another one?
yeah,
Okay.
we can figure out how to make
Somebody's not
money
gonna
with it.
go every day on the building.
What's that?
Somebody at home is not gonna go every day on the building.
Yeah, and I want to make sure, I don't want to go away from sand to have to do it, and I want to make sure that it's something I have faith that is gonna be operational in 10 years.
You don't have any interest?
well, yeah, we have an interest. I mean, I think, you know, we were an early adopter. I think we got benefits from a reduced odor standpoint, even working in the manure when shit happens and you got to get your hands in it. The digested manure is different. It will wash off, the stink will wash off your hands a lot quicker and.
Wash your hands, you eat dinner and not control.
Right. So, yeah, I mean, we'd have an interest, but everything's based on size now. All the focus, you know, when our digester went down, I applied for some grants, got some grants. Part of the challenge is this renewable natural gas from digesters is such a big thing that there wasn't a lot of interest and there's a limited community out there to support these things. Our flare failed because there was no support for us, you know, type of thing. So
Our kids don't want anything to do with digester. They got enough to manage.
I have the interest. I'm not sure the rest of them.
It takes the way that can make it work. It's gonna be another part.
Yeah.
So does how it's gonna work for these other companies that
Yeah.
say they're gonna run to take care of them? I have a hard time believing it because I saw what we had to put into on the farm, keeping the digester running. There was a commitment to it. It didn't run on its own. We had to maintain it, we had to keep it running. And I don't know if that's one of my concerns with an outside company running a digester, do they really have the equipment to do it?
I would agree with it.
We used to be 90 pounds a cow. We're only running 85 now, but we switched when the quotas went in to get components and just fed the cows 73% forage diets, amongst other things. Extreme components, very low involuntary cull rate. We sell bred heifer or early lactation milking first calf heifers every spring. Got 2 farms, we'll buy everything we got. So we get some other side incomes in. Time we lowered the grain costs down and components went up. Even though we went down 5 pounds a cow a day, it was the same dollars. We won a quota and we didn't lose any money at all. And the cows are, without a doubt, it's a lot nicer running with the high super forage diets.
So you all operate separators. Can you speak to your kind of annual maintenance costs and what goes into maintaining those systems?
You're gonna, in ours, we have 2 dotas running, and you're gonna have to replace the screens annually. 12 to 13 months, new screens and augers. So yeah, you got costs there, and I can't tell you offhand what it is. It's a fair amount. They're stainless steel.
How many cows you said you're going through that? How much manure?
Not quite 1,100.
1,100 cows. So.
Well, it's 1,200 going through with manure wise. So 2 new screens and augers every year.
It's less than the bedding cost. I don't know the exact.
Yeah, I would guess.
It's a lot less than the bedding cost.
You also
Oh, yeah.
have to be ready to, when the manure pump is plugged or got a foot block or something stuck in it, it's gotta be pulled and fixed or you can't pump manure. Whereas that doesn't happen as often with some of the other systems.
Yeah, because it's not just the separator, it's an agitator, it's another pump, and it's a more finicky pump because it's a smaller diameter and all of that.
Yeah, you can get stuff in it, and ours is just a hydraulic winch. Pull the hose off, it runs up. You have to get in with a sleeve, breeding sleeve, pull out of the bottom, whatever's in it. And it happens, and several times a week. But our person that does all the feeding, he also manages the manure system, and he's just checking it as he does that group. He'll check that pump in that group and then go on the next group. He'll check in the main system. It's all one man does all the feeding and manages the manure system.
Our excess solids have been provided with fertilizer also. We're able to take those to places where people won't accept liquid anymore. You can use solids. I mean, we're already in the village of Adams, so we put solids out every year, and there's more people stealing solids from us than there is complaining about that.
It is a nice neighbor relations. Tell them, come get a truckload of manure solids for their garden or whatever.
Helps the neighbors, yeah.
Okay, hi, I'm Kirsten. I'm sorry I wasn't able to join you guys this morning. I was really interested in the conversation, but it's the time of year where we get double booked a lot, so. Just curious, those in the room who are farmers who have P-index used on their nutrient management plan. Okay, planners that have to utilize the P-index when planning with farmers. Couple. People who have no idea what the P-index is. Perfect, okay. Awesome. So Justin asked me to come and take this opportunity to share a little bit about the P-index. And so that will take up a big chunk of what I talk about today. My goal with this part of the presentation is to help explain what the P-index is, how we use it, and that it's not this black box that we just shove information in and you get a result and you're stuck with it. That there's a lot of agency there we can use to use it as a true management tool. And then sort of build on that when you'll see the P-index helps us get to a point in planning where you may end up in a phosphorus-based or a nitrogen-based manure application scenario in certain fields on your farm. And so given the discussion of today, how do we use that to sort of make these larger, bigger picture, whole farm nutrient decisions? And one of the things I want to do is thank Jason, who, without which the second half of my presentation would be impossible. And I'll just share with you that in general, I'm going to throw a lot of scenarios. I'm wishing that it was bigger, so you're gonna have to get out your reading glasses. There's a lot of numbers. Don't take any of them as like actual real life numbers or precise examples. A lot of this is just scenarios trying to put in context some relative differences throughout my conversation. I also, interrupt me. I'm pretty informal, so if you have questions or I've not explained something right or I've said it inaccurately, just pipe up. Okay, I think we're there. So the first thing I'm going to do is just tell you what we're going to talk about today. I'm going to explain why we have a phosphorus index in New York. We have, some people call it a new P index. It's new for some of us just using it, but the new version 2.0 has been out since 2019. Talk a little bit about how it's different and how it works. And then, like I said, we have a few scenarios. I'm going to gloss over a lot of those for the later part of the conversation. And then talk about implications of separation covers and moving away from sand and how that might impact your operation. So a little background, the phosphorus index is a risk assessment tool that we use in nutrient management planning. If you have a nutrient management plan, whether that's a comprehensive nutrient management plan to comply with our CAFO permit, or you're working through AEM, or just are interested in what we call a 590 nutrient management plan, the national NRCS, who sets all the standards for the practices we use on farms in this way, basically said we need to have some way of managing phosphorus. We've identified, I should go back one, right? This is what we're trying to manage for, is reducing harmful algal blooms in our freshwater bodies. We know that phosphorus can be a driving factor, and so we're trying to reduce those phosphorus losses so that we can improve and protect water quality. So in order to do that, NRCS says we need to be paying attention to how we apply phosphorus, especially when it comes to our manure. And so you have a few options. We have these national standards that then become state standards, and each state can approach them differently. And so what they told us is that you can either use your soil test, land grant, university guidance, right? So that's one option. And if that's the case, if you have a soil test over 40 pounds of P per acre Morgan, you basically don't need any more phosphorus in order to grow, this is for corn, to see a response in yield from your corn crop. So if we went that route, anyone with more than 40 on the soil test would get a 0 recommendation for manure or phosphorus fertilizer. And you can see here the max would be about 65 pounds of P5 per acre. So just keep that in mind. However, Okay, and then the other would be like, we're gonna set a threshold. Once your soil test gets to a certain threshold, you're not allowed to put on any phosphorus at all. And then the third option is to use a risk determination tool, and that's where the phosphorus index comes in. And we're not the only state with a phosphorus index. All the Northeast regional states, Wisconsin, other folks use that same approach. They might have a little different algorithm behind it, but a lot of folks have a phosphorus index. So one thing I like to remind folks about is, why would we ever, if the soil test tells us you don't need any more phosphorus to gain yield in your corn crop, why would we want to put on more than the soil test recommendation, right? And so the P index helps us do that, and it governs sort of these upper limits for manure application. We want to utilize manure on our farms, right, to the best way possible. And those land grant university guidelines, some of which have my name on them, right, are assuming purchased fertilizer. So it does you no good as a farmer to purchase more fertilizer if we don't expect you to see a yield response from that application, right? That's a little different when we start talking about manure, because there's other beneficial uses of manure as well as other nutrients we're trying to balance for. Which I just said, look at that. It's like I've talked about this before. Some of those beneficial things, right? We're going to be increasing soil carbon, improving soil structure, reducing erosion, increasing infiltration. And we see a yield bump actually from manure applications above and beyond what we see in the actual nutrients in that manure. Okay, so if we put, we expect to see a certain tonnage from the nitrogen in manure, but we actually see it go above and beyond that because of all these other factors from manure. And right, these other benefits are offsetting some of those environmentally unfriendly purchased fertilizer, right? So when I talk to watershed planners and environmental advocates, I like to remind them that we don't want to be importing more nutrients into our watershed. So if we have manure nutrient resources on our farms, let's maximize those first before we start importing more nutrients into the watershed. And the P index helps us do that while also mitigating risk, right? The other thing we know is like not every pound of phosphorus that we apply above and beyond the soil test recommendations are lost. That's not how it works, especially with phosphorus. So while we do want to mitigate for loss, we know that by applying over the soil test recommendation doesn't mean every single extra pound you put on disappears into the water. And then the P index has these cutoffs, right? So if your soil test is over 100, in most cases, and in all cases, if your soil test reaches 160, those fields you'll see won't be allowed to have manure applications or phosphorus fertilizer applications. And the P index really is designed to keep us from getting there, right? So it's allowing that best use of manure, reducing fertilizer imports, and mitigating for risk. So it's actually a good thing we have the P index. Originally these phosphorus index were not meant to be regulatory necessarily. They clearly are now, and we know that. So, I think we would have to say the 2019 version, we knew the context in which it was being used, but it's not just a regulatory tool. They're designed to really help the farm and the planner make these management decisions. So it helps us kind of rank our highest risk fields, and then apply the right best management practices to those. It really isn't a black box. It seems like it. I'm sure you guys get those binders where you're filling things out in a spreadsheet and you're like, okay, what does that mean? But hopefully by the end of this presentation, you'll start to see that what we do on the field and making changes in our plan and our farm can actually impact the results of our phosphorus index. So if you're changing management, which many of you have, right, in the last 5 years, 10 years, 20 years, we should be reflecting those changes in your plan and in the P index. And again, this is a long-term management tool to avoid getting us to those really high soil test Ps where we do know phosphorus risks are higher, and to have a situation where your farm would be tight and be restricted for your manure applications. And there's some end benefits in here too from some other practice that it encourages. So just real quickly, I'll move through this. The old P index, right, had a source score and a transport score. Both were dissolved in particulate phosphorus. And then that gave you a ranking. In all of that was your soil test and your timings and your methods and your rates. And you got a score, and that was either N-based, P-based, or no P, and we'll talk about what that means. The new P index sort of flips that on its head a little bit. So what we do is we take sort of what we call the raw score now. This is like mostly the inherent things about an individual field that might create risk. And that's your raw score. So if you only look at your raw score, your eyes might get big, right? Those of you that have used the tool, it's like, oh, right? So we look at all of that, both for dissolved and particulate, but then we multiply it by this BMP coefficient. So if you're doing any best management practices that reduce risk, that raw score gets reduced. And I'll show a few examples of that. And then we look at it actually in the context of your soil test P. So you'll see that each of these low, medium, high, and very high scores might mean different things depending on your soil tests, and then ends up in the same sort of management-based decision. So I'm just gonna, that's like the same thing. I do have a couple of the manuals, real thick, kind of boring in the back, but there's also a 2-page fact sheet if you want to learn a little bit more about how the P-index works and have some reminders of what I covered today. But basically, it's sort of a 4-step process. So the first thing we do is we'll screen for high soil test P. Like I said, we determine that raw score, we apply the BMP coefficients, and then determine what that management implication is. And this is kind of what it looks like. So step 1, right? Why run the P-index if you know it doesn't matter what you do, right? You're going to end up with no manure being allowed on an individual field, right? So if we have fields over 160 pounds of P per acre Morgan soil tests, you will not be allowed to apply manure or phosphorus fertilizer there, right? Those are our highest risk sort of situations and matches the NRCS standard for that.
Just for everyone in the room, that's incredibly high.
Yes, and very rare, frankly. Like, I don't know about all of you that look at soil tests, but very few fields, especially on dairy farms, do we see that number very often. There might be 1 or 2 fields, right? The ones near the barn that got all the solid manure back 50 years ago, right? We do see some, but generally speaking, like, if we see that, we're like, paying attention. So we don't even run the P-index because we know what the answer is going to be, right? Okay, so then you don't need to read this other than to know that we have like distance to stream plays a role, how, if there's any vegetation in that flow distance, how often does the soil flood? A lot of it is soil type dependent. This is the only piece in this raw score that deals with management. So we run the Russell that estimates erosion on each field. And that does kind of play a part in this initial raw score. And then the presence or absence of these concentrated flows and whether or not, you think about those areas of the field that are draining water. And if we haven't managed those to not be eroding, those are 2 areas where you can actually have a little bit of implication on the raw score. And we do it for dissolved and particulate, and then whichever one's higher is the number we use. And then we start applying these BMP coefficients. So we have 2 buckets. One is sort of your method of application. How are you applying your manure? The second is in what context? What's the ground cover? What's the timing? How are you doing it? So if you've done nothing, right, you're surface spreading, you have no setbacks, that's not a BMP, right? So your coefficient reduction is, right, you multiply by 1, which is not a reduction. Similarly, if we're applying manure on bare ground and outside of sort of our planting window, also not a BMP. So you don't get a reduction, but we can go all the way down to 0.5 if we're injecting and 0.5 if we're doing that into a growing crop. So you're going to multiply by both of those coefficients. So you could take a inherently high score, right, and reduce it pretty significantly, which I'll show you right here in a second. So again, right, depending on where we land, you're going to be somewhere in this chart. And you can see as your soil test is lower, you have more N-based options. As your soil test gets higher, you might be limited into phosphorus-based management. And if we're in these very high, so this is a very high P-index rating and sort of independent of your soil test, that's also a situation where we would be worried. So N-based is essentially, you can apply manure or fertilizer to not exceed the annual nitrogen needs of the crop. So that means you're likely maybe over applying phosphorus depending on how you're applying. If you're in P-based management, we say you can apply a manure up until the crop removal rate of phosphorus of that crop, and then you got to stop, and then you got to make up the difference in fertilizer, or 0P is 0P. So what's that look like in real life? Or for those of you that are planners having to work with your farms, right? I mentioned you can really drastically decrease your score. So in this example, I'm saying that we started with a score of 100, which would be very high, and you'd be locked out of applying manure. But let's say in scenario A, you were surface spreading, but it was in a hay field and you were set back 35 feet. So you had a 35-foot buffer and you were spreading on that growing sod. And so your score got reduced by 0.7 and again by 0.5. giving you a score of 35, which is the N-based management pretty much no matter how you cut it, unless you have 160 soil test P. Okay, or you're somewhere in the middle, right? You're surface spreading, you don't have a vegetated buffer, so you stand back just a little bit more from where that water field leaves the field, 100 feet, and you've got some whole plant, residue out there, corn stover, something like that out on the field. So that gets you to 56, or you do nothing, right? And your score stays at 100. So depending on where that lands you, right, that best case scenario, you're going to be mostly N-based with some P-based as your soil test gets a little high, again, because we want to keep you from getting here. So if your soil test is here, even though you're doing really good management, we're like, okay, don't overdo it, right? And then similarly in that middle category in the blue, medium, you have 3 different options. And then if we do nothing, that field's been locked out. So as you adopt these BMPs, right, your options sort of open up in how you can apply and allocate those manure resources. So sometimes I get a little stress from farmers and planners about P-based rates. So for the farmers in the room, your planners are trying to keep you in compliance, right? So they tend to use a pretty conservative approach when we're using these tools so that no matter what you do, you'll be in compliance with your permit or the BMPs and not having runoff. So sometimes people call that like a worst case scenario, right? They're planning for like the least amount of conservation practices. But what they're trying to do is just know that if you can't do any of those things, right, can you still be applying phosphorus and be in compliance? So if they were to do the opposite, right, and plan for the best case scenario, you're doing everything perfectly. What happens in those moments when you can't? And so they don't want to write a plan for that either. So what's happening and what we're seeing with this new version of the P-index is we're starting to see that probably the approach we're going to start seeing is more of a, what I showed before, where you'll have a few different scenarios. You do nothing, this is your result, you're no P. You do some level of, like if you're injecting on all your cornfields in the spring and that's just how you roll, or you're cover cropping every cornfield on your farm or whatever, and that's going to happen, 97% of the time, you can probably start planning for that. Right. But if it's something else that's a little bit more dependent on weather and other things, right, we got to kind of split the difference and also have that backstop of like, okay, what about if when, the worst case scenario happens or I have to put manure out in a situation. Some other things here about P-based management is often if we're doing any level of incorporation injection, those P-based rates get us pretty close to nitrogen. And so we'll talk a little bit more about that here. So let's say I'm P-based and I'm growing an 18-ton crop of corn silage. I did a little bit of pretend math that says 10, 10, 7, and 20 on that manure analysis up at the top. So I can't go above 70 pounds of P2O5. So my rate is set, right? 10,000 gallons. Well, if I inject that 10,000 gallons, I'm getting what I need for nitrogen, right? If I wait a day to incorporate, I get pretty close. I need another 20 pounds of nitrogen. It's probably what I'm going to put on in starter anyway. So you can see how that changes. And if we leave it and don't incorporate it all I'm getting is that organic nitrogen credit. And I'm going to be putting on a lot of fertilizer in that field. Now, one of the things I like to remind people is using real yields and using real manure tests is important. And the reason why is, let's say we're on a farm and actually their manure test is only 5 pounds of P2O5 per 1,000 gallons, and they're actually growing a 20-ton corn crop, right? Their P-based rate just went up to 15,000 gallons, not 10,000 gallons. And if I was injecting, I'd actually be over applying phosphorus, or nitrogen rather, and I might back off that rate anyway, okay? And so I could go up to 50, even within, 3 days of incorporation, we're back to that sort of starter N application in fertilizer. So P-based rates are not the end of the world. And then we get into nitrogen-based rates, right? And we think about, okay, well, if we're meeting the nitrogen needs of the crop with manure, we are likely, in some cases, unless we're injecting or getting some timely incorporation, over applying P2O5 and potash. And that's kind of what this looks like. So if I take, and I say that I'm in a low-risk field, I can apply my manure for nitrogen, I can do that at that same 10,000 gallons injected and not be over applying phosphorus. I could be incorporating within 1 day. That means I can up my rates because I've lost some nitrogen up to 13,000 gallons per acre. But now I've over applied P2O5 by a little bit, and depending on your soil test, that might be, not a bad deal, or it could be getting you into trouble eventually, and then I can even, and this is just some level of incorporation up to 17,000 gallons. But now I've over applied P2O5 by about 50 pounds per acre. We'll start to do that year after year after year. We'll start to see soil test phosphorus build up in some cases. So again, just like all the other numbers I'm going to share with you guys in a minute, that has lots of implications, right? So depending on you have more manure and less acres, right? Then you might want more gallons per acre. But if you've got not enough manure to cover all your acres, okay, whether we're injecting, incorporating, right? We have different implications in terms of, you know, this is acres covered by 1 million gallons. You can just see if I'm injecting, I can cover way more acres with that rate. Here, I'm only getting 59 acres covered with that same 1 million gallons because I'm applying up to 17,000 gallons. So we have to, again, think about those trade-offs. And again, right, if we're not incorporating and if we're doing all of our applications in the fall, we just got to recognize that we're experiencing nitrogen loss. And so we'll be purchasing that nitrogen and you know, just knowing that that's an environmental loss as well. There is a little bit of flexibility in the P index. Does anyone here have a whole farm mass balance for their farm? So if you're operating under the whole farm mass balance, which is a little bit of a grosser math problem, we take all the imports and all the exports off the farm, divide the balance by the acre. If you're operating for 3 years at less than 12 pounds of P per acre for the farm, you get a little bit more flexibility. And the reason that that was built in is that if you're going through that next level of sort of analysis, gathering all those records, keeping track year to year, measuring your yields, all of that, and you're managing under that threshold, we feel like that should be rewarded. And so that was built into the 590 standard and the P index now with 2.0. And so if you are, you get a little bit more flexibility. So this is what that chart looked like before. And you can see that these 3 categories get unlocked to end-based management. Because we feel like you're showing another level of sort of management on a whole farm level. We feel like you're not, you know, you're in balance and you get a little bit more latitude to be planning in that way. So just a few reminders about flexibility in your plan. Make sure we're using your specific yield records, right? Otherwise, you're using the yield index. And for most farms that are managing at a pretty high level, you're probably getting higher yields that are in the yield index in our land grant university guidelines, because those are averages, right? So use real yields, because that will up your rates, even if you're in P-based management. Maximize those realistic BMP score reductions. And if you can, utilize that adaptive management option. And those are ways to sort of help that pool be a little bit more flexible. So you'll start to see these rolling out if you haven't yet from your planners. I think they're welcome to questions and sort of situations of how we can communicate this tool to you all better in your plans. We have lots of conversations I've had with Terry and Justin and other folks in the room about how do we like wrap our heads around this. But I do just want to say, right, so we want to maintain productive, optimum soil test P for the long haul. Not get you to a situation where you're in trouble and need to get cut off. And I do have a couple scenarios, but I kind of want to get to the next part of the presentation unless you guys have specific questions. I'll just give 2 just to show you. There's a calculator, there's a spreadsheet. I'm sure you guys are all going to run home and download it. But this is the kind of stuff I do. I run scenarios, right? So here is a field that has a soil test P of 40 to 100 pounds, some other things going on, and their score if I'm surface applying in the fall is 120, and it gets all the way down to 48 if I'm injecting in the spring. But look, does the rate change? I got to end base, but I got there through injection, so my rate doesn't actually change, right? But it's very low risk. Okay, also that same result, but with a lower soil test P has a slightly different implication. And if I'm injecting in the fall, I can get to end base. That'd be a lot of manure to put all your nitrogen in from your manure in the fall, even if you're injecting. So it just gives you a few examples. Okay, I'm gonna move forward here. Okay, any P index questions before we move on? Okay, so Justin asked me to like try and wrap our heads around a little bit how the stuff you guys talked about this morning about if we're not using sand on the farm as bedding, if we're separating solids, If we're covering storages and not having rainfall in our manure pits, what that might look like in terms of, you know, nutrient management, storage capacity, and sort of the things I deal with. I'm not going to cover everything. I'm going to try and stay in my lane. But I think you guys have probably talked about already this morning that these are systems approaches, right? It's not like you just change one thing and that's it and walk away, right? It affects the whole farm. And so there's going to be trade-offs. So just like keep that in mind as we talk. The other piece here is I made some assumptions. This is not real. I call it based on a true story, right? This is not real life. But I had to start with some numbers. You should see the spreadsheet. Jason can tell you it's a little ugly. But you know, I just try to keep it simple. These numbers are not precise. They're meant to show relative differences as we make certain changes. So don't like take these numbers and print them somewhere. They're just like how I wrap my head around decision making. So I assumed 1,500 milking cows. I didn't take into account any young stock. I used the state average of 40 inches of rainfall per year, used some book values for nutrients. We made the changes that we see in nutrients based on manure technologies, sort of in the mid-range of those estimates. And again, in a couple of situations, I saw a higher density farm with 1.2 animal units per acre and sort of a lower animal density farm with 1. But again, not real life, but based on it. So, you know, as we start converting from sand to solids as bedding, we think about, okay, well, I have this whole source of something on the farm, right? An input on the farm that I'm not importing. We think about that when we talk about the whole farm mass balance, right? What are all your imports? Bedding is an import. So if sand is what you're using for bedding, right? How does that impact the farm? So less volume, right? It's one thing that's not ending up in the barn and in the manure pit. Also, we've seen some benefits, right? We know that sand's tough on equipment. Like we make that decision because it's good for one thing, and we know that the trade-off is that we're going to have a little bit more maintenance on equipment. Thinking about then if we have solids, it's not like that's a management-free situation either. And then what if we're just separating sand? And I'm sure you guys talked a little bit about that too. I don't talk about that too much here, mostly just talking about the volume of it not going into our storage. In general, right, as these systems all play together, there's going to be some potential financial costs, right, that will increase, and some potential savings where we'll see some cost decrease. These are just a handful of them, right? There's like the increases in infrastructure, or, you know, new infrastructure you might need to invest in on the farm. There's operation and maintenance costs related to those, but right, if we're storing and applying less volume, we have less wear and tear on our equipment. One that I didn't even think about until the last field day we were at was this idea is as we separate manure, we don't have sand or solids or less solids in the pit. We actually don't even really need to agitate, right? Because we've sort of gotten rid of that piece. We're avoiding some purchases of spreading or sand rather. And this idea, actually Justin reminded me of, which is like, we think we're applying, you know, whatever's in the tanker, but if the tanker's, you know, 10% full of sand, we're actually not applying that much, and it takes more trips to get the same volume of manure to a field. There's, I'm sure.
How many of you spreading sand climbing your trucks to clean sand out?
Yeah.
Do you wear a personal gas meter when you do that? I would encourage you to, right? It's a confined space, you know, so there's also just the safety concern.
Yeah. Yeah. No one's favorite job to get in there and clean out the sand, right? Okay, so again, rough numbers, I use book values, just the volume of sand that's not going to end up in our pit in a year. And this is going to be different for every farm, but just to give you an idea, if that's 50 pounds per stall per day at 120% stocking density in your barn, we have removed about 1.5 million gallons of volume of stuff in the pit. Okay, so we're not spreading it, and I'm using pumping numbers here at a cent, you know, 1 cent per gallon. We've saved $15,000 a year just from not pumping that, right? That volume is gone. In addition, many custom applicators charge a little small upcharge for pumping sand. So if none of our manure has sand in it and we don't get that upcharge, right, we can save another $19,000 on that 1,500 cows worth of manure. Just kind of ballpark, right? So $34,000 just in sort of our pumping savings. But what about nutrient impacts from sand, right? We've removed this whole source of import onto the farm. But what we need to remember is that sand doesn't have nutrients associated with it, right? It's inert, it's mineral. So as we reduce sand, we actually don't change our whole farm nutrient balance at all. The volume changes, right? But total nutrients don't. I've heard some farms talk about, yeah, but I have heavy soil. The sand's like good for my soil health and soil texture. Some people say like, really, like it doesn't really add up to that much. And some folks say it's actually a lot of sand you're putting out on your field. And there can be some trade-offs there too, in terms of when we see differences in capillary action, right? When we have like a lot of sand up here and a different soil texture down here, we can see infiltration actually slow down. We lower the cation exchange capacity in the root zone, and we can decrease organic matter, just in terms of the concentration, right? If you've got a lot of sand, but I would pay less attention here to this. I think, you know, the big picture here is you're not changing the nutrients on the farm, really. Questions about that? Feel free to throw tomatoes at me about my math. So then now we're talking about separating solids, and how does that impact sort of the nutrient dynamics and the storage dynamics on the farm, right? We think like, right, as we take out those solids, there's nitrogen, phosphorus, and potassium attached to them. That's less volume going into the pit, but now we have different streams of manure, and depending on what you're going to do with those solids, that could be a benefit or it could be a challenge, right? So if you're using it for bedding and that makes sense and you're set up for that and you've built your system for that, that's great. Or maybe you're actually hoping for that so that you can have this lighter material that you can truck to our farther away fields, add some organic matter. It hasn't got manure in a while. That could also be a benefit. So we just ran a few numbers there too.
Depending on what your goal is in
Yeah.
separation, some farms who are just trying to export, you know, they don't have to get it right in the screen. They don't have to really like dial that separator as tight.
Right.
They're just trying to pull some solid.
They're not drying it. They're not, yeah, exactly. Yeah, so if you need it as an export, again, that's the other, you know, benefit. If I'm like looking away for to export manure, am I going to export liquid or could I export these solids off the farm? So just looking at the volume and nutrient concentration, so we assume a 10% sort of volume reduction when we pull the solids out. And this took me a minute to wrap my head around, but I finally got it last night. So the concentration of the liquid after that separation doesn't change that much, right? We're seeing like less than 1% change in the resulting liquid, but we have a net decrease in volume, right? And in that volume, it's taken about 11% of the total nitrogen, most of it in the organic form, about 25% of the total P, and 7% of the total K. And again, those numbers are going to be different depending on your situation. But the resulting liquid concentration doesn't change all that much. But we do have less volume. Okay, you're gonna have to squint on this one. So then I think about like, well, how many nutrients do I have available on the farm? So this is assuming I'm taking those solids and not spreading them. I'm looking at this, is this a way to like reduce the nutrient load onto the farm? Okay, so we've had a difference here. We reduced, you know, in the teens of thousands, right? Our N to P ratio, you know, got a little bit better. And we did see some reduction in nutrients on the farm overall. So what does that mean in our spreading, right? So if we take that volume of manure and put it across all our acres, which doesn't happen on any farm, right? So again, these are just to show you relative differences, right? We go from 4,500 gallons per acre down to 4,100 gallons per acre if we're a lower animal density farm. And we go, you know, we have a difference of about 500 gallons per acre if we're at a little bit higher of the density as a farm. But we have all these solids, right? So that'd be about 7,000 tons of solids. And we said how much would be in there and what that looks like. So basically, if you're that lower density farmer spreading at, you know, 3.4 tons per acre, again, that would be across all your fields, which would be a really low rate. And then a little bit higher if you were a higher density farm. So what about if you're in that P-based management category, right? So I'm in P-based management, but I still want to get gallons out. And if I've separated my solids, I've lowered some P. And so if I'm applying based on that 77 pounds of P2O5 for a 20-ton corn crop, that would normally with raw manure be about 9,000 gallons per acre. And that would get me available 122 pounds of available N, where with that separated liquid, I'm upping my rate a little bit and I'm getting a little bit more nitrogen as a result. So there is some difference there. Okay, This is where things get interesting. So first of all of this, we don't really know the numbers for real yet. Jason and Lauren and myself, we're like trying to wrap our heads around this. We're trying to work with you guys that are implementing these practices to quantify the actual reductions. These are all just hypothesized reductions, right? And this would be one in particular I think we need to know more about. My assumption here, I just want to remind you here when we're talking about covering storages, keeping that water out, we're still figuring out what that looks like. How does water evaporate when it's in a manure pit sitting in a pond, right? How does that happen, and how much savings might we actually expect to receive? We don't know. So this is assuming no evaporation, like best case scenario, right? But basically, right, same idea. We'll have less volume to spread. Will that manure then be a little more concentrated because we've got less dilution, right? What will the N to P ratio be? Is it going to help me if I'm in P-based management? Those are the kind of questions we're trying to answer. So I used just an example manure pit. So it's 200 feet by 350 feet in dimension. That's about 1.6 acres of surface area. It holds about 5.8 million gallons operational, right? So allowing for freeboard and all that. And we assume that 40 inches of rainfall. I just want to remind you, we're sort of up here, right? But depending on where you are in the state, you could go from anywhere from, 35 to 45 or 50 inches of rain a year. So recognizing that. And I'm not assuming any of that evaporation. Again, we know it happens. We just don't know at what rate. And the 1,500 cows.
So no evaporation assumed, but also no accounting for snow melt and the other.
Yeah, and snow blowing in. Exactly. So if I haven't covered that manure pit, I can expect every year between manure and rainwater to see 10 million and change of volume go into that pit, not all at once, right? If I cover it and keep that rainwater out, I've reduced it by 1.7 million gallons. That gets us to that 8.6 million gallons total. This number represents about 30% of the storage capacity of that storage. And it's about 17% of the capacity of the total manure being produced by those 1,500 cows that goes into that pit. So not insignificant. And again, if we go back to our 1 cent per gallon pumping cost, that's another $17,000 in savings from not pumping that water, which I think all of us that pump manure think like, how come we're spending all this money and time pumping water everywhere? Right. So it's going to vary depending on how often you fill the pit, how often you empty it, like all of those things. But that just gives us a fairly good idea. So the way I think about it is like, well, how many days of storage does that give me? Right. As we come into April and we get a rainstorm and pits are getting full, but we don't want to be out there spreading today. How many more days do I gain? So that same 1.7 million gallons, right? That I'm keeping out of that pit. If I'm not covering my manure, and I'm not separating, that manure pit holds about 187 days of storage for those 1,500 cows. If I separate it, but don't cover it, I go up by about 17 days. I now have a little north of 200 days of storage. If I've separated it and now covered it, I've given myself an extra 58 days. Now, this is best case scenario, right? So, but that's where I, think about that in terms of when we have storages and we're trying to manage those manure resources in the best way possible to protect water quality and preserve nutrients. This can be an important part of the decision. That's up to you. Do you want to spread them? Do you want to bed with them, or do you want to export them? Yeah, they don't go away, right? None of this makes the nutrients go poof, right? It's mass, like we're moving them around. So you have to decide what you want to do with those solids. And that's the question you need to ask before you invest in any of this, right? Okay, so how does covering your storage change the nutrient concentration in that resulting manure? We expect that it should go up, right? Because we're reducing dilution. These numbers are based on like very limited information from manure samples from a covered storage before it got covered and after. It was already being separated.
Yes.
So the only thing that changed was the cover got put on the pit, but very limited samples. And we know how manure samples can change from year to year, right? So,
Representative that little.
yeah, this much manure, whole pit. So,
Especially once it's probably eventually.
Yeah.
right. So not sure what this is telling us, only to say, we don't have a lot of data on storages. We expect concentrations to go up. In this particular situation, we actually saw organic nitrogen go down. I was like, that's it, I'm taking this one out of the slide. And then Jason reminded me like, well, that doesn't totally shock us, right? We've kind of created almost a semi-anaerobic situation that would foster more of that degradation of organic material because we've covered it. We did also expect to see a fairly significant increase in that ammonium nitrogen. It's not volatilizing off the surface of the manure pit. We kept it covered. So, you know, that seemed to match with our hypothesis. But it's going to be really important if we've now shifted our nutrients to this more soluble form and more volatile form, then we better be doing a really good job managing that nitrogen then, right? So if we're applying that manure in the fall, right, that's more apt to loss. If we're surface applying and not injecting or incorporating, more susceptible to loss. So just, again, like there's always going to be this tension and, you know, push and pull when we do any of these things. And then in terms of P-based rates, it doesn't make a huge difference. It's not enough of a change just from covering to change your rates too much. The rates go down a little bit, which we would expect. You also have less manure to apply. So I feel like it's probably a little bit of a wash when it comes to P-based management. If the only thing you change is the cover. Now, if we change the cover, the separation, the same, like all of it, then we see a change, but not just inherently from the cover itself. So this goes back to Terry's question and some of the things Jason, and I'm sure the things you guys talked about today, I'm not going to like harp on it, but like you got to be asking yourself the questions. What are you trying to accomplish through any of these practices? And then picking the right strategy and whole system that we hopefully meet those goals. So are you looking to get your manure across more acres, and separating it gives you this like latitude to have this other stream of manure that you can haul further? That might be a benefit. Or maybe you're tight, and so separation helps you export in a more feasible manner. You know, if maybe I'm tight on storage, so I really just want to keep less volume of anything going in those manure storages. But then we got to set ourselves up for like, what am I going to do with separated solids? Is that something I'm dedicated to managing for bedding, or is it something I recognize is going to be sort of another management strategy for export?
So for me in that discussion, look at that separated solids, you're going to use that first initial block for bedding, unless that's burning up, so to speak, in the beds. Once you use that first 10% or whatever it is of sand solids for bedding, then you just got the same number of solids thereafter, because you don't really have destruction of those fibers. So
right.
You don't have to stockpile that.
Right.
And I don't know too many guys in here that are looking to export in the north side.
Right.
So therefore, then we got storage issue on
Yep.
the solids.
Yeah, now you've created a whole nother waste stream to not waste stream, a whole nother nutrient stream to like have to manage. Right, and you probably don't want it just sitting out there. You probably want it covered. Like there's a lot of trade-offs there for sure. And it won't be 100. I mean, there'll be some loss over time. Those fibers will degrade and get smaller.
Fibers go back through the manure system again and again. They break down more and more, and then they're not caught by the screw press, right? And so you don't suddenly your pile doesn't get bigger and bigger.
Right.
You do have this other, organic material demand.
Yeah. And some people compost it and export it. Some people are just land applying it. Some people, yeah. But if, like you said, Terry, I don't know a lot of farms. They're just like, whoa, I have too many nutrients on my farm. I got to get rid of some. So.
I don't know, from the farmer panel, Dale, I mean,
yeah,
you make it just you and the cover, right? So you're under you're most challenged to manage it well. You produce more solids than you use for bedding.
Most of the guys I know don't produce enough solids for the bedding they want. Most don't.
We produce more than we need for bedding.
Okay. We produce, we're bedding all our young stock facilities too. I don't have solids to spread, but I got young Stein, I got 250 heifers on pack barns. We load in 10 wheelers and haul 8 miles away. Put it on temporary piles in the field, go in the spring or fall and spread it. It's all legal by people. I ain't gonna haul liquid 8 miles, but I can haul solids that far.
Exactly.
And run a payloader and 2 big box cutters down in the spring or fall and cover ground that would never see manure before.
Right.
Very similar to most of our excess solids. That's what we do with it. We are selling some at this point too. limitedly, but yeah, mostly putting it in places where liquid manure can't go.
But it's not like piling up and you're like, oh my gosh, it's taking over my.
It's good for mortality compost as well.
Yeah.
Right? Those kind of uses on farm.
We have several landowners that are absolutely against liquid manure, but are perfectly fine with solids. You know, we try to develop as we can do some, like some lakeshore property, that those people don't like liquid manure, but they're fine with the solids in the backyard.
Doesn't work as well with composting, that stuff. Doesn't aerate as well.
Yeah.
You need air to hold up through the pile of compost in order to make it cook better. You can't get air to move through the solids pile.
Not porous enough.
Yeah.
Yeah. All right. Well, I'm out of time, so happy to answer questions. I probably don't have all the answers to them. I'll probably ask Jason or other people, farmers in the room to help me, but I appreciate the invitation. I appreciate the exercise of going through all the numbers. And now I have a spreadsheet. So as we get more data, we just start plugging those numbers back in. So thank you.
Any other questions? Or comments?
I think you gotta have a cell and restricting, if you gotta pump that water off.
Yes.
So you say from, there's another cell there.
Yeah, so we do have to pump that water off. And one thing I do want to say about pumping the water off is like, okay, is that water clean? Is that water dirty? Depends. And if that water's clean, can we discharge it? And if it's something that we're gonna like land apply or put in a pond, right? Where's it gonna go? And I've seen good situations and less good situations, but let's not have it create like a unintended consequence. Or pumping it off and it's like creating erosion in the field or, you know, doing something else. So that's a really good point.
Well, good afternoon, everyone. For those of you who don't know me, I'm Mike Durant, and district technician for the Scottsdale on water. Next up on our agenda, we have a funding panel put together that's going to talk about some of the cost share opportunities for the practices we've been talking about today. At least for Lewis County, for the programs available to ag markets. Myself and my coworker Alexi will be the first people you want to talk to. For Jefferson County, or be Justin and his get it all up. Next, I'll introduce our funding panel. Start over here on my right, the Greg Albrecht. Greg is our AEM coordinator in New York State through ag markets, and Greg came over with this today. After Greg going to speak, we have Tom Pratt. Tom is our resource contact for USDA-NRCS for here in Jefferson County. And last but not least is Mary Scoville, the executive director for the Farm Service Agency for Jefferson and Lewis County. That's not more than this. So, all right, with that said, I'll turn it over to you, Greg.
Mike, thank you very much. And Justin and Jenny and everybody that was involved in organizing this, really appreciate you putting together a good program here. I should also say, if there's anybody from St. Lawrence County here, this is the St. Lawrence table. And if anybody made the long trip from Cayuga County, there's the Cayuga County table of soil and water districts as well. So thanks for coming. And then just want to cover some of the programs that Ag and Markets and the New York State Soil and Water Conservation Committee organized at the state level and that are absolutely locally led and delivered and seen by your county soil and water districts at the county level. And certainly my colleagues, Ryan Cunningham from our shop that oversees the Northern New York soil and water districts and our programs, and Scott Fickbaum in Central New York, Southern Tier in the back. You've got other questions from our level. Okay, so the punchline with all of these are, well, let me ask this question, a better way to do it. Farmers in the room, who's worked with your soil and water conservation district before on grants? I think that's pretty much everybody, right? So great, that's step one is develop a relationship and build it and work it and stay in touch with each other every year, because program offerings, thankfully in the soil and water district world, are there every year. Sometimes they change, or in recent years, they've been growing every year. So there's good opportunities there. And as you can imagine, anytime any of these developments that we're talking about on farms require a lot of thought, and they, engineering, planning, a lot of input and feedback and review and revision tasks for districts and partners to make it right, because you've got to live with it, you got to want it, you got to operate it day in, day out. It's got to be efficient. and meet your goals. So, you know, talking early and often is good. And if, you know, a grant comes out and things aren't quite lined up, you know, have some peace in mind that there'll be another grant next year and you've got the process going. And by then you'll have, you know, an ironed out plan. Everybody's on the same page. Dale and his family hosted a field day last week looking at the cover and flare systems. And your brother Ray just really well summarized, you know, what it takes to make these tick. And it's a team, right? It's key staff on your farm. It's your AIM certified planner that does your CAFO permit planning. It's the soil and water district. It's NRCS involved. It's NRCS. It's your professional engineer. It's everybody on the same page. And then even today, right? We talked about how you know, it could be your nutritionist, it could be your vet, it could be your herds person. That's really important in these conversations to make us get the best out of these programs. Absolutely, our funding programs that are under the bar there, under the Ag Environmental Management Framework from ag markets and locally led through the districts, are meant to build on your successes, improve your farm's productivity and management, and also continue to lead on environmental management. And that's with as our understanding grows, that means more and more. That means air quality, that means water quality continuing, and certainly soil health and other elements. And that's how we're updating and revising our programs to be able to serve all those needs and support you in your leadership roles in that. Because I agree with the farmer comments wholeheartedly. They're leading the way, and you know, that's the future of ag and dairy in the state. Everything's based on your CNMP, your plan with your AIM certified planner. And I want to talk about very briefly 3 of our main funding programs that are offered annually. And again, if you want to know more about these in a real specific, farm specific way, you know, get in touch with your soil and water district. So there's the AIM base program, and that allows the soil and water district staff, along with other funding that they've done there, to go out and meet with you on your farm and pull together key players, like I was just talking about, to make a project a success without having to charge you. And it also has a modest cost share component. Our longest running one is called the Ag Non-Point Source Grant Program. That's been going since the early 90s. And that is primarily water quality and soil conservation focused. But most of those practices also have knock-on benefits for things like greenhouse gas mitigation as well. So, and then our latest one, which has been running for several years, and I'm about to tell you some more details about round 8 or year 8 of it, is the Climate Resilient Farming Program. And its design is to mitigate greenhouse gas emissions from agriculture, improve carbon sequestration, help with adaptation to extreme weather events that we're seeing with extra water, extra drought, you name it, improve soil health. And then with a new track that I'll explain in a minute that's focused on the forest lands that we have on farms, or even tree planting within underused parts of your farm that maybe you haven't planted, harvested, or generated any revenue from in recent years. There are other programs, and Tom's going to summarize those, so I won't get into those from NRCS and FSA. You want to point out, keep your eyes peeled for a revised CAFO funding program, specifically for CAFO farms. You might remember a few years ago, there was one that was focused on expanding our manure storage capacity. Did anybody participate in that one with your district? There were some leftover funds from that, and we got permission to reallocate it, and it's going to be reallocated with the first round coming this summer. I think we're going to try to release it during Dairy Month in June, and it's going to be focused on water quality and also greenhouse gas emission mitigating. So a little broader set of practices and a broader set of goals for that than its original offering a few years ago. With this slide, I always like to firmly acknowledge that, you know, this is great. It's helped good public-private partnership, but there's a significant private investment element from you and your farm budgets that make these tick, both to not only the cost share to be able to implement the project during, the contract with the Soil and Water District or with NRCS, but also your ongoing investment in the day-to-day operation and maintenance of it that make them function and tick. Once you've adopted those into your, daily management routines of the farm. The effectiveness of this, it doesn't work without that. Okay, so some details about climate resilient farming round 8. That request for proposal is going to be out this month, and it will run through the later part of June, and awards made during Climate Week in September. And it's broken out into tracks of somewhat similar practices so that they can be ranked at the state level in more of an apples to apples way. So track 1, and I'll kind of focus on that for this in the next slide, is all about manure management and precision feed management, primarily for farm productivity, water quality, and the big one, this is unique to climate resilient farming, greenhouse gas mitigation, a lot of what we've been talking about today. Track 1B is focused on one component of that, cover and flare projects, but with federal funds that we are awarded a grant for and are able to sort of wire into this program. Track 2 is about adaptation and resiliency, and that is focused primarily on flood and drought mitigating activities on farms and a wide swath of practice systems you can imagine to accomplish that. Track 3 is about healthy soils and also agroforestry. And track 4 is the new one that we're kind of piloting this year, and that's focused on the forest lands that are on your farms. And it could be proper silvicultural forestry work to advance regeneration of tree growth and carbon sequestration in your forest lands. It also could be tree planting on, scrubby, currently open lands, if you think of it that way.
So Greg, around here, there's a lot of, buckthorn shrubland. So could they get money to both mow that down and then plant trees, or would that be decarbonizing that piece of land?
Yeah, good question. So I want to acknowledge there's a group of district foresters that helped us with the technical elements of this new track and the training, the Soil and Water District and partners on it. And Pat Crafts was really instrumental in helping us with that, and really value your efforts in that. So the site assessment of these open lands, let's call them, is really critical to gauge the natural regeneration potential of it. So there's a bunch of desirable hardwood species that are in little seedling forms in there. We wouldn't want to mow those down. We'd want a forester to come in and make a plan to help them grow up. And then as they continue to grow up, you pick the winners and call the losers, and you've got a forest there, right? If that site assessment says, there's nothing of value here, then that's also an option in this track of burning it down, mowing it down, maybe some herbicide elements there too, and picking species and tree planting. Yep. And there's also an open opportunity for work in your woods to help with regeneration too. Jenny, I know I'm supposed to focus on manure and stuff like that, but I wanted to expand a little bit to show this. Okay, I know you didn't say that, but all right, fair enough. Is that cool? Does that kind of give you a thumbnail sketch of it? Again, talking to districts, even though the RFP is not out yet, was approved by the State Soil and Water Conservation Committee last month, and it is not too early to talk to districts about this. All right, super small, but I wanted to highlight some things that were more squarely with what we've been talking about today. This is track 1A. It's funded through New York State funds, and it's focused on all things greenhouse gas mitigating related to manure management and feed management. So you can read off those things: manure storage, cover and flare, separation, moving animals out into well-managed grazing systems. So maybe I'm not storing as much manure, that's going anaerobic, but it's being applied by its own. And also feed management. We haven't been taken up with many feed management projects yet, but that is so far, quite open to work with obviously the sponsor, the soil and water conservation districts, but likely the technical folks would be a consulting nutritionist and the key staff on your farms to perform precision feed management on the farm, better meet different herd groups where they're at nutritionally and consistently deliver that so that we're making the concept that was discussed a couple times, milk with less waste, milk with fewer inputs of nitrogen, phosphorus, and carbon, and therefore less unused nitrogen, phosphorus that goes out the back end, and then methane that's belched out the front. All good things that you've been, by the data, steadily advancing on for decades, but we all know that there's more to do. And you gave a really cool example, John, of what you've done with raising heifers and what impact that's had on the carbon intensity of your milk. Okay, so but what we came here today to talk about is essentially in the categories of manure treatment systems. So there's funding for solid separation systems, and that's en route. It has a greenhouse gas benefit on itself, but truly with the program, it's to prepare in a phase to then cover and flare the storage, maybe in a future round of funding. So it's to prepare in case doing separation and cover and flare project all in one shot is too much to bite off in one project. Bedding alternatives. So you've got a facility that needs some of the retrofits that we've talked about today to switch from sand to bedding with separated solids. That's eligible. We haven't seen one of those projects yet. This has been around for a few rounds now. It's any of the elements within the barn or downstream in the manure system to make that possible, where we could separate the solids and ultimately cover and flare the storage. That is done with the intention that the storage would be able to be covered and flared at some point in the future. I think that says about it, and I was supposed to be quick on that. I want to talk a little bit. We've got this unique point in time where we do have a federal grant that we're allowed to plumb through our state program that's locally run by districts, and that's going to be called Track 1B. It is exclusively focused on manure storage, cover and flare projects, but because of the nature of the grant, we're able to offer 100% cost share on that, and it could include some other components there too, where solid separation isn't in place or three-phase power to make that tick isn't in place.
Yeah, so if you're interested in cover and flare, they'll pay for it all.
Yep. With the federal grant, it comes with some modest reporting requirements that we're required to deliver to the USDA. It's all under the confidentiality and data sharing that you have if you participate in federal programs, and similarly if you participate in state programs under the AEM law. But the grant comes with some additional reporting, and you have to be enrolled with FSA for that and compliant. Yep. Sorry, Terry. No.
So there's some kind of necessary.
No, not for a covered ambient temperature manure storage. If it's with thermophilic, anaerobic digester, then yes. But for just a cold anaerobic or a cold manure storage that's covered and flared, we were able to have DEC Division of Air articulate an exemption for that.
Is that something new?
5 years ago, 4 or 5 years ago, that went in. Kurt Gooch helped us back in the days of that, and he was on staff for there. Yeah, it was pre-pandemic. Yeah. Yep.
So you have to have an air quality from the bread digester, but not the flare on the cover.
That's correct. That's correct. Yep. And, yeah, so, yeah, if anybody's done a digester project, you've been connected with DEC's, Division of Air folks, and I'll do that too. I'm gonna step aside and share the stage with Tom, I think is next, maybe. But there's some closing thoughts just to reconnect with your district if you have interest in any of these things. And let us know if we can help otherwise. So, thanks, Jim. Thanks, Mike.
Hey, everybody. I promise to be quick. I like public speaking about as much as the rest of you probably. So I'm Tom. I'm with NRCS in our Watertown office. Jenny and then Justin had asked me to speak on some of our programs. So NRCS has several working lands programs. The goal of these programs is to address resource concerns such as water, air, and soil health is another one that we've been going after lately. Each program is specified to go after certain ones. So EQIP right now, the big thing is air and water quality. We work with customers to ensure these programs meet what you guys are after. I always say, don't tailor your operation to the program. Do your operation it is, and we'll make the program fit your operation. So our main program we have is EQIP, or the Environmental Quality Incentives Program. This program comes around once a year. We take applications at any time. It just depends when they announce when the sign-up deadline is going to be. Usually that's sometime in September-ish. There's two tracks of funding right now. There's the normal EQIP that people have dealt with for years, where all of our practices are available. And then there is IRA, which is the Inflation Reduction Act. That gave us $19.8 billion that we have to spend by 2027. And then that money has to be used in those contracts by 2030. And that's meant for use on greenhouse gases, so covers and flares, separation units. I believe covered barnyards is back. And there's a few other things through that program. So the overview, it's directed for us to use these funds specifically for climate change to help reduce the greenhouse gas emissions and air quality concerns associated with farming. We're seeking to benefit both the climate and greenhouse gases and to help you guys limit your current emissions. This is just a few of the practices. So there's a few practices that are available in IRA. It's not your normal EQIP practices that are available. There's select ones. So like feed management's one that's available, roofs and covers. So if you need to cover a barnyard, putting roofs over a sand separation system, anaerobic digesters are available, and waste storage facilities are available also, and caps and flares through this program. Other programs we have are CSP, the Conservation Stewardship Program. That program is a little bit different. It hasn't been pushed as heavy. I don't know how many guys in here have heard of that program before. Are you currently enrolled in it? Do you enjoy it? It's got its ups and downs. It's not. Okay. It's not on our side. It's kind of the headache program. It can be paperwork intensive at times, depending on the practices you pick. If you don't pick real crazy practices, it's not bad. It's a 5-year contract. It's a set rate. Minimum payment is $4,000 a year, max of $200,000 over the 5 years. And the nice part is after the 5 years, you can re-enroll again. IRA is also available through CSP. So you can, those same practices we spoke on just a minute ago, you can do those in CSP also. AMA is another program we have. It's a little bit newer. They've changed it. It's meant more for like how Shelmidines have some farm or fields that are close to high density population areas to help treat issues with that. So we're helping to mitigate risks with those in the public in that program. All of our programs are set rate. We don't have anything like Greg that's 100% cost share. They usually say we shoot for that 50 to 75%. That's a ballpark. As we say, if we pay this rate, if it costs you more, sorry. If it costs you less than that, well, congrats, you made a little bit of money in the process. Everything has to be installed to NRCS standards and specifications. I think that's pretty much it.
Do CSP and AMA count towards the farm bill cap of 400?
They do not. So they have their own. So EQIP's a $450,000 cap, and then you can also put the 200,000 CSP cap together. AMA's cap, I'm not sure if they have a cap at the moment.
No, Kirsten, on that reminds me, those federal funds that we got through one-time grant, we were plumbing through ours, that cap does not apply to those. But those projects can't be matched with what Tom's talking about now, so.
If you do, I think it's the 1B, correct?
Yeah.
We do have a few projects that I guess they've figured out how to do them together. We have to separate the components.
Yeah,
So
there you go.
if you guys are paying for a flare, we can't pay for the flare. We have to go for something else in those projects. So you can put them together. It's just a little more paperwork to figure it out. So typical steps with us, you got planning, your application, eligibility, ranking, and then your implementation. So planning, usually say, give me a call. We try to come right out. If it seems like it's something you guys are interested in, then we'll move towards the application phase. If we think it's gonna be a waste of your time to do it, then you don't ever get to the application phase. Everybody's welcome to put an application anytime. We try to get ahead of that, so then we're not wasting your time. So this is a little bit better breakdown of it. This is how I usually put it in my words instead of the flyer they give us. So application is accepted year round, as I said. Typically the cutoff for funding pools such as 2025 will be in the fall of 24. I always tell everybody we're a year behind. So if you want to do something, try to look 2 to 3 years out. We're not exactly the quickest moving agency in the world, because I'm sure some of you that have dealt with us have noticed. It's usually something with policy. If yours, after your application, we go through the planning process. This is where we figure out how to make sure things fit your farm. The little loopholes and the nuances of the programs to make things work for you. After that, and we've come up with something that you guys are happy with, we move into the ranking part. And that's the plan that's developed between NRCS and yourself. We rank that. That's where you compete against everybody else. That's now done in a computer system. Everybody's assessed on the same questions. So everybody's treated fairly. There's no favoritism at all in that. And that typically occurs in the winter months around February. Pre-approval, once they decide to announce when they're going to do that, it's usually end of February, beginning of March. They go through and they select applications, however much money we have, they go that far down the list. You get notified whether or not you'd like to move forward. Then we go into obligation, which is generally between March and June. Right now, I'm actually in the middle of that paperwork nightmare. And then it's a contract after this point, and then the fun part begins of getting it built or implemented.
I have a question for you, Tom, while Mary Jane comes up.
Okay.
In my perception of what's going on here, right, when you do an application for the climate resilient farming, it's like a full-on application, right? Like there's a whole process for that deadline. But for your deadline in June or September, whatever it is, it's just a 3-page application indicating an interest in planning, right?
Correct.
So like this deadline he's talking about is just to begin discussions of the planning, and it's really simple 2-page or something like that document, right? So it doesn't commit you to anything the way that the Soil and Water Conservation District do CRF and Ag on Point is a much more like the application is like this beefy product that you're putting forward. I just want to make that distinction that their slower process starts out really simple.
Our application is 12 questions, and the longest one is you have to write your name and address. After that, it's just checking boxes, and you can withdraw an application anytime, and there's no penalty on you. You have right up until you sign for a contract to withdraw with no penalties, no questions asked. Okay.
Mine's gonna be real short and sweet because Farm Service Agency doesn't have any funding as far as the manure storage. Our funding is more in the loan area when it comes to like farm storage facility loans that deals with commodities and stuff. What we would do, we would work with NRCS as far as like this program goes. And when you do your application, before you do your application with Tom, you'd make an appointment to come into our office and we would get your pertinent information. So we would be attaching you to a farm. You have to be attached to a farm for an application. We have to get your get you into our database. So that part of it's pretty simple process to apply for the EQIP program, but we handle the administration part of it more. So that's really all Farm Service has for.
And connected to Greg's comment about the federally funded cover and flare climate smart commodities, can you just speak to how that farm needs to be affiliated with FSA in order to apply for that?
So anybody that applies for any of the programs has to obtain what we call a farm serial number. So what we tell, most everybody, the farmers here all have farm serial numbers with their agencies. But if you're a new customer, you would want to bring in like your tax ID parcel. We have to outline you on a map and give you a farm serial number and put you on as owner and operator of the farm. It's fairly simple. And then usually you have to file an 80-1026 form to be in compliance with highly erodible and wetland conservation.
This has been a production of Cornell University, on the web at cornell.edu.